Hello everybody. Warm welcome to Home Institute. Very good evening to everybody. Please let me know in the chat box. Am I audible to everybody? Warm welcome to Home Institute. Is my screen visible to everybody? So, please let me know in the chat box. Am I? Yeah, I think from my end everything looks clear. Okay. Okay, fine. So just let me check. Right. Okay, guys. So, as the name of the session itself indicating, we will be discussing, top 50 questions. In fact, not 50. I actually prepared 70 questions. Okay. Based on the time, we will see whether 50 is possible or 70 is possible. PS Bimbra textbook is one of the standard textbook for electrical machines. Most of the electrical engineering students know about this particular textbooks. Um, One of the best textbook, I must say. And at the back end of the textbook, there are number of questions given. Okay, from electrical machines subject. Okay, covering various aspects of electrical machines. When I counted, there were more than 550 questions from PS Bimbra itself. But we cannot discuss all the questions in the live session. It will take hours and hours of time. So what I feel is that according to the syllabus we have, okay, in AP AEE examination, I selected some of the best questions from PS Bimbra textbook. Okay, and I hope most of you might have practiced these questions during your preparation. And this particular session will be helpful for those who wanted to quickly revise electrical machines. Okay, so that we can solve some of the important models. And you see, I selected questions which are of AEE level standard. Okay, not at gate level, which are at AEE level standard. Okay, right. So without wasting much time, so we will try to start the discussion. Okay. See, I just used scanned copy of PS Bimbra textbook. I don't have time to type everything, so I just took the scannings of PS Bimbra textbook using my phone, and I just cropped the images of the required questions, and I just pasted here. I hope it may not be so clear for you, but I hope you can understand at least. Okay, you can read the question. That is more important. Okay, and we should be able to answer the questions. Okay, and one point I would like to mention: most of you might have already practiced these questions. Frankly, I would say some of you might have by-hearted these questions also. Generally, ఎందుకంటే there are rumors or there are previous instances where directly textbook questions appeared in the final exams. That's why some of the students and most of the students might have by-hearted these questions. But this time it will not be like that. I am expecting none of the question as it is will be given in the AEE examination in the upcoming exam, because AP Transpo CMD was seriously conducting this exam. Okay, and you cannot expect questions like regular AEE exam. You will not find any copy paste kind of questions, but they might have taken the concepts are more important. That will be useful for you. Okay, anyway, let's start answering the questions. You please keep posting your answers in the chat box. That will help us. Okay, right. Okay, guys, so now see this. The torque angle delta is defined as the angle between. Actually, torque angle will be represented with the letter lambda. Load angle will be represented with the letter delta. So this is a basic concept from rotating electrical machines subject. In rotating electrical machines, electromagnetic torque will be defined as, it will be directly proportional to minus F1 F2 sine lambda. Okay, so this is the general electromagnetic torque equation in rotating electrical machines, where F1 is the stator magnetic field MMF, F2 is the rotor magnetic field MMF, and lambda is the angle between stator field and rotor field. For example, this is the stator MMF. Okay. And here we have the rotor MMF F2, and sum of these two, the resultant MMF, we also call it as air gap MMF. This is air gap MMF, and this is lambda. Lambda is nothing but the torque angle. So torque angle is the angle between stator magnetic field and rotor magnetic field. Okay, so it is the stator field and rotor magnetic field. That is option C, the third option. Okay, so load angle is different, torque angle is different, guys. If it is load angle, it will be between rotor field and resultant field. Okay, but a torque angle is the angle between stator field and resultant field. Okay, fine. Now, so I selected not, simple questions. Okay, I don't want to waste your time. Okay, in case if you have already practiced PS Bimbra questions, I suggest you keep away from this session, or at least after my live you can watch a recorded session at 1.5x speed or 2x speed. This session is seriously important for those students who started their preparation very few days back, or those who have not completed entire electrical machines, or those who have not practiced many questions. Okay, if you are good with electrical machine subject, you can stay away from this session and you can use this time for other subjects. Okay, yes. All right, let's move to another question. Two three-phase AC generators are such that one has twice the linear dimensions of the other. Okay, so the important data is one machine has just let me use the best color for you. Yeah, so one machine has twice the linear dimensions of the other. The field windings of each are excited to give identical air gap flux density. See, flux density is identical in both machines. Okay, both have the same number of stator slots and also identical winding patterns. The conductors per slot in bigger generator is K times that of the smaller generator. Now, what is the value of K in order to get equal no-load voltage at the same frequency? Equal no-load voltage at the same frequency. Okay, so all right, guys. Okay, any issues about live streaming, please let me know in the chat box. Okay, any issues with audio or video, please let me know. Okay, it's a rainy season, sometimes the network may slow down, or sometimes sudden power off may happen, so please let me know in the chat box if there are any issues. Okay, guys, so now the point is, they are three-phase AC generators. Generally in AC generators, what is the formula for induced EMF? The generated EMF is equal to 4.44 into flux density, field flux density into cross-sectional area of core, frequency, number of turns into winding factor. This is generally the EMF equation. All right. Now they said very clearly both machines are having same flux density. All right or not? Okay. But cross-sectional area is different. Why? One machine is having twice the linear dimensions of the other machine. Okay. And the number of turns are different. Number of turns are different. See, bigger generator is having K times that of the smaller generator. Therefore, I can write the induced EMF is directly proportional to area into number of turns. Frequency will be constant, same speed, and winding patterns are also same. So same winding factor. Okay, identical winding pattern. That means the pitch factor and distribution factors are also same. So therefore, EMF is proportional to area into number of turns. And what is the question? We want equal no-load voltage. For both machines, same amount of voltage must be generated. If you wanted to create same voltage, number of turns and area must be inversely proportional, right or not? Okay. So, and you see, the bigger generator is having twice the linear dimensions. What is the unit for area generally? Okay, generally the unit for area is meter square. When I say all linear dimensions are doubled 2 times, can I say area will be 4 times indirectly? So therefore, the number of turns and area are 1 by 4 times. Okay, if area is 4 times, number of turns must be 1 by 4 times. Okay, if area is 4 times larger, 4 times larger, turns must be 1 by 4 times. 1 by 4 times. Therefore, in the larger machine, number of turns are k times. That k is nothing but 1 by 4. So if number of turns are 1 by 4, then only the voltages will be same in both machines. Understand? Okay. Now, same question may be given in your final exam, but exactly same question they will not give. They will say linear dimensions are doubled, and they will also say flux density is double or flux density is half. Then density will also be a variable quantity. So you should be able to answer question in any manner. Okay. So the answer here is exactly 1 by 4 times. Okay. Right. Okay. One more question. This is also from basics of armature winding design. Remember guys, your examination is having a calculator. Calculator is allowed. Okay. That's why you can expect numerical questions also in your final exam. Okay. That's why I selected questions which is balanced manner. Okay. Right. In a 48 slot, 4 pole, 3 phase alternator, coil span is 10. 10 in the sense 10 slots. Okay. Its distribution and pitch factors are respectively what? Okay. Distribution factor and pitch factor. You see, coil span is 10 slots. So first we have to find out a slot angle gamma. Generally, what is the formula for slot angle gamma? Gamma is equal to 180 degrees divided by slots per pole, correct? So this will be 180 degrees divided by how many slots are there? 48 and 4 pole. 48 divided by 4. You can use calculator. I'm using a gate calculator. Okay. It's always encouraged if you find answers quickly rather than me, you can post in the chat box. Okay. You are much faster than me usually. 180 into 4 divided by 48. Okay. So the slot angle is equal to 15 degrees. Okay. If each slot angle is 15 degrees. Now what is the coil span given? 10 slots, right? So coil span means beta, 10 slots. So 10 into each slot will occupy 15. Therefore, the coil span was 150 degrees, right? The coil span, this is coil span guys. Coil span is 150 degrees. If a coil span is 150 degrees, then what is the short pitch angle? Therefore, the short pitch angle alpha is equal to 180 degrees minus beta. 180 degrees minus 150. So therefore, short pitch angle is equal to 30 degrees. If a short pitch angle is 30 degrees, what is the pitch factor? Pitch factor is equal to cos alpha by 2. So alpha is 30, so alpha by 2, it will be cos 15 degrees, right? So if you use calculator, cos 15 degrees, yes, I am getting 0.965. 0.965. The pitch factor is 0.965. I got 0.965 available here, available here. That means C and B both are wrong options. Okay. Now let us find out distribution factor also. Okay. What is the formula for distribution factor? Sin m gamma by 2 divided by m sin gamma by 2. Okay. What is the m value here? M is nothing but slots per pole per phase. You calculate on one side. Slots per pole per phase. And in the given question, 48 slots were given. And there are 4 poles. And how many phases were there? It's a 3-phase machine, right? It's a 3-phase machine. Okay. So 3 phases. So 4 into 3, 12. Is it not 4? Yes. M value is equal to 4. Everything is available, just to substitute. So sin 4 into 15 degrees by 2 divided by 4 into sin 15 degrees by 2. If you use calculator, you will be able to find the answer. 60 by 2, sin 30, 0.5 divided by 4 divided by 7.5 sin value. So I'm getting 0.957. The distribution factor is 0.957. 0.957. Yes, here it is 0.957. So therefore, the last option is the correct answer. Okay. All right, guys. Okay, fine. So the last option is correct. Option D. Yes. So most importantly, the coil span was given. Coil span is 10. They did not mention anything. 10 in the sense 10 slots. If each slot occupy 50 degrees, 10 slots will occupy 150 degrees. Therefore, the short pitch angle will be equal to 30 degrees. That is how pitch factor can be identified. Okay. Now, this is an important question. I don't want to solve questions which are like, V1 by V2 equal to N1 by N2. V1 will be given. You are asked to find V2, or slip is equal to Ns minus Nr by Ns. These kind of questions I don't want to solve in this session. I wanted to solve some important questions which will be useful for your exam. Okay. All right. Now, consider the following statements. Breadth factor or distribution factor, both are same. Breadth factor for third harmonic is more than that of the fundamental harmonic. Okay. KD3 is more than KD1. KD3 is less than KD1. KD3 may be less or may be more depending upon the number of slots and pole. Coil span for third harmonic, this is a pitch factor, guys. Okay. KP3 is greater than KP1. KP3 less than KP1. KP3 may be less or may be more than KP1. Okay. Can you guess the answer? You take, I request all of you to have a paper and pen with you and try to solve along with me so that it will be easy. It will be good practice for you. Okay. Right. Come on. So generally, distribution factor formula, you see, they did not mention how many phase machine it was. So I default assume it's a 3-phase machine. Okay, you can take 2-phase or single phase also. We know majority of power system is 3-phase, so I'm assuming 3-phase machine. Now they are talking about distribution factor. What is the formula for distribution factor with respect to fundamental harmonic? Sine m gamma by 2 divided by m sine gamma by 2. But we all know that where gamma is a slot angle, if slot angle gamma is very small, sine gamma by 2 can be treated as gamma by 2. Generally, you might have seen sine theta is almost equal to theta if theta is very small. In a similar manner, sine gamma by 2 can be approximately written as gamma by 2. So then this is sine m gamma by 2 by m gamma by 2 into pi by 180. Why I have to multiply with pi by 180? Because gamma is an angle in degrees. So to convert the degrees to radians, we will multiply with pi and divide with 180. Now, for example, if it is a 3-phase machine, this m gamma is known as phase spread, and that phase spread will be equal to 60 degrees, guys. If it is a 2-phase machine, m gamma will be 90, single phase 180. Okay, so you just substitute that, then sine 60 degrees by 2 divided by 60 degrees by 2 into pi by 180. What is sine 60 by 2? Sine 31 by 2. So it will be 1 by 2 by 60 by 2 into pi by 180. So 2 will cancel. 60 will cancel 3 times. It will be 3 by pi. This is the approximate value of fundamental distribution factor. Now you try to calculate third harmonic distribution factor also. What is KD3? Now third harmonic ante em cheyalandi manamu? So third harmonic means the angle gamma must be multiplied by harmonic number 3. Then it will become sine m into 3 gamma by 2 divided by m sine 3 gamma by 2. All right. Again, sine m gamma by 2, I can directly write this. Just a moment, guys. Okay. I can just directly write this as m into 3 gamma by 2 into pi by 180. We all know m gamma is 60 degrees, then 3 into 60, 180 by 2, so sine 90. Sine 90 degrees divided by 180 by 2 into pi by 180. So what is sine 90? 1. 180 will cancel. This will be 2 by pi. Okay, so therefore what is the comparison right now? Yes, fundamental distribution factor is a 3 by pi, third harmonic distribution factor is 2 by pi. So what is the conclusion? Therefore third harmonic distribution factor is definitely less than fundamental distribution factor. Okay, so KD3 is definitely less than KD1. So second statement is true, first statement is wrong. Okay, KD3 more than KD1, it's a wrong statement. Okay, third statement is also wrong, right? Because we already derived KD3 is less than KD1. So 1 and 3 are definitely wrong. 1 and 3 are definitely wrong means two options are already eliminated, right? Okay, now look at the fifth and sixth statements. That is about pitch factor. What is the formula for pitch factor, guys? Fundamental pitch factor is cos alpha by 2. Third harmonic pitch factor, it is cos 3 alpha by 2. That means you see, when you come from fundamental to third harmonic, angle is multiplied by 3 times. If cos of angle increases, what about the product value decreases? Okay, so Kp3 is definitely less than Kp1. అంతే కదండి, కాస్ 0 1 అండి, కాస్ 90 0 అంటే కాస్ లో యాంగిల్ పెరిగే కొద్దీ కాస్ ఆఫ్ ద యాంగిల్ ఏమైపోతుంది, తగ్గిపోతుంది అనమాట. సో దేర్ ఫోర్ Kp3 ఈజ్ లెస్ దాన్ Kp1. ఓకే, సో యు సీ Kp3 లెస్ దాన్ Kp1, Kp3 గ్రేటర్ దాన్ Kp1 రాంగ్, ఇది కూడా cannot define is wrong. So what is the correct answer? 2 and 5 will be the correct answer. That is option A. ఈ టైప్ ఆఫ్ క్వశ్చన్స్ చాలా ఇంపార్టెంట్ అండి. 4-5 స్టేట్మెంట్స్ ఇచ్చి ఏ స్టేట్మెంట్ కరెక్ట్ అని అడగడం, ఇది జనరల్గా మనకి పిఎస్యు లెవెల్ ఎగ్జామ్స్, ఏఈ ఏడబ్ల్యూ లెవెల్ ఎగ్జామ్స్లో జరుగుతుంది. బట్ దిస్ క్వశ్చన్ ఈజ్ ఎక్స్ట్రీమ్లీ ఇంపార్టెంట్. ఓకే, రైట్, ఫైన్. ఓకే, ఆల్ రైట్. Now let's answer questions related to transformers. Okay, transformers నుంచి నేను అప్రాక్సిమేట్ గా ఒక 15 to 18 క్వశ్చన్స్, ఇంపార్టెంట్ క్వశ్చన్స్. నేను ఒకటే గుర్తుపెట్టుకోండి, నేను గేట్ క్వశ్చన్స్ చెప్పట్లేదు, ఐఈఎస్ క్వశ్చన్స్ చెప్పట్లేదు. పిఎస్ బింబ్రా టెక్స్ట్ బుక్ బ్యాక్ సైడ్ ఉన్న క్వశ్చన్స్ లో కొన్ని ఇంపార్టెంట్ క్వశ్చన్స్ తీసి మీకు చెప్తున్నాను. అన్ని టాపిక్స్ కవర్ అయ్యేలాగా ప్లాన్ చేశాను, సో దట్ ఇట్ విల్ బి ఎ గుడ్ రివిజన్ ఫర్ యూ ఆల్సో. ఓకే, రైట్, లెట్స్ సీ. For understanding the behavior of transformer, the following laws may be called for. Okay, this is an easy question. I am expecting answer from you guys. Come on, what is the answer for this question? For understanding the behavior of transformer, which of the following laws are you called for generally? Okay, yes, definitely Lenz's law. Lenz's law, what is the purpose? ఓకేనా, మీకు నెక్స్ట్ ఎగ్జామ్లో ఇలాగే రాదండి క్వశ్చన్. వాళ్ళు ఏం చేస్తారంటే లెన్స్లా దాని పర్పస్ ఏంటి, టు ఫైండ్ అవుట్ పొలారిటీ ఆఫ్ ఈఎంఎఫ్, టు ఫైండ్ అవుట్ మ్యాగ్నిట్యూడ్ ఆఫ్ ఈఎంఎఫ్, ఆర్ టు ఫైండ్ అవుట్ మ్యాగ్నిట్యూడ్ ఆఫ్ ఫ్లక్స్, అలా నెంబర్ ఆఫ్ స్టేట్మెంట్స్ ఇస్తారు. ఫస్ట్ థింగ్, లెన్స్లా విల్ బి డెఫినెట్లీ యూస్డ్. దిస్ ఈస్ టు ఫైండ్ అవుట్ పొలారిటీ ఆఫ్ ఇండ్యూస్డ్ ఈఎంఎఫ్ ఇన్ సెకండరీ ఎస్పెషల్లీ. ఓకే, పొలారిటీ ఆఫ్ సెకండరీ వైండింగ్, దానికోసం ఖచ్చితంగా మనం లెన్స్లా యూజ్ చేయాలి. Next one, Newton's second law, it is not used in transformer. Yes, Faraday's law of electromagnetic induction. Faraday's law యొక్క యూజ్ ఏంటండి, టు ఫైండ్ అవుట్ magnitude of EMF. టు ఫైండ్ అవుట్ magnitude of EMF. EMF యొక్క magnitude మనం ఎలా రాస్తాం, ఇండ్యూస్డ్ EMF is equal to n d5 by dt. ఈ magnitude తెలియాలంటే that is because of Faraday's law of electromagnetic induction. Next, Ohm's law. Yes, Ohm's law is always used in every electrical circuit. Okay, ఎలా Ohm's law ఎలా ఉపయోగపడుతుందండి, కేవీఎల్ ఈక్వేషన్ కదా. ట్రాన్స్ఫార్మర్ లో సప్లై వోల్టేజ్ V1 ఉంటుంది, వైండింగ్ రెసిస్టెన్స్ ఉంటుంది, లీకేజ్ రియాక్టెన్స్ ఉంటుంది, దెన్ ఫైనల్లీ వీ హ్యావ్ ఇండ్యూస్డ్ EMF. సో యూ కెన్ అప్లై కేవీఎల్ ఈక్వేషన్ హియర్. సో V1 ఈజ్ ఈక్వల్ టు E1 ప్లస్ రెసిస్టెన్స్ డ్రాప్ ప్లస్ రియాక్టెన్స్ డ్రాప్. డెఫినెట్ గా Ohm's law కూడా యూజ్ అవుతుంది. ఓకే, next, Fleming's right hand rule. No, Fleming's right hand rule is used in rotating machines only. In rotating machines, to find out polarity of induced EMF, we will use a Fleming's right hand rule. The first 3 fingers are placed in a mutual perpendicular direction. Conductor movement, magnetic field, polarity of induced EMF. ఇది మనం rotating machines లో యూస్ చేస్తామండి, like DC machine, induction machine, synchronous machine, not in transformer. Next, right hand grip rule. Yes, right hand grip rule is also used. How right hand grip rule is used in transformer? Yes, to find out the direction of a flux. For example, I gave you a transformer core like this. There is a winding wounded. If a current is passing through transformer winding, we will be asked to find out the direction of a flux. ఎలా తెలుస్తుందండి? Right hand thumb rule. We also call it as right hand grip rule. So based on the direction of current, you can identify the direction of a flux. So this is how right hand grip rule or right hand thumb rule is also used in transformers. So final ga manaki correct answer enti 1, 3, 4 and 6. 1, 3, 4 and 6. Therefore option D is the correct answer, right? Okay, fine. Option D is the correct answer. Okay na? Options ని ఒక్కొక్కసారి మీకు ఈ 6 స్టేట్మెంట్స్ లో మీకు all 6 statements you may not know. Sometimes maybe 3 or 4 statements you know. You may not be sure about other 2 statements. Then you can eliminate options, right? Definitely Newton's second law is not used. 2 is definitely wrong answer, right? Fleming's right hand rule we will not use. 5 is definitely wrong answer. Then at least you can identify A or D must be correct. Then as negative marking is not there, you can pick any one option, so probability of getting correct answers will increase. Okay, right. Next, yes, go through this question. In a single phase core type transformer, LV and HV windings are arranged as under. How LV and HV windings are arranged in core type transformer? This is construction of the transformer. Yes, transformers are basically 2 types, core type and shell type. In core type transformer, we will use concentric winding design. Concentric winding design ante enti? We will design LV winding and HV winding, we will divide into 2 parts. Okay, LV winding and HV windings are divided into 2 parts. Then first LV winding will be placed on top of the transformer core. Total LV and half of the LV, half of the LV. But don't forget, insulation will be there. On the top of insulation, winding will be mounted. Okay, now this is half of LV. Next, we will take remaining half of HV. Then a half of HV will be placed here. Half of HV. This is one side of the core. Then on other side also, first we will place half of LV. Then we will place remaining half of HV. Remaining half of HV by 2. This is known as concentric winding design. Okay, so therefore the correct answer is half of LV. Who is near to the core? And if you stand from the core, or if you see from the core point of view, who is near to the core? Yes, LV winding is always near to the core. Okay, so therefore half LV near to the core and half HV outside LV on each limb. Therefore the last option is correct. Okay, got it? Yes. And ఈ క్వశ్చన్ చదువుతున్నప్పుడే మీరు కోర్ టైప్ ట్రాన్స్ఫార్మర్ యొక్క ప్రాపర్టీస్ అన్ని చదివేసేయండి. When you are going through this question, you try to recapitulate all the core type transformer basics. Core type transformer is used for, yes, high voltage, high power application. Shell type, low voltage, low power application. Core type transformer, concentric winding design. Shell type transformer, sandwiched winding design. Core type transformer, more leakage flux. Shell type transformer, less leakage flux. ఎందుకంటే క్వశ్చన్ ఎటువైపు నుంచి అయినా రావచ్చు. ఓకే, yes. All right, next, one more question. Please go through it. It's a numerical question. It's a numerical question. All right, go through it. Whether your answer is correct or not, please try to post in the chat box. Okay, right. వర్చువల్ క్యాలిక్యులేటర్ ఎలా యూజ్ చేయాలి అని నన్ను చాట్ బాక్స్లో అడిగారండి. యూర్ ఆల్ ఇంజనీర్స్, రైట్? You should not ask me how to use calculator, isn't it? You must learn on your own. isn't it? It's not a difficult thing, right? You cannot ask, how to use calculator. Okay. I don't want to waste your time doing such kind of videos. Views కోసం ఏదైనా చేయొచ్చండి యూట్యూబ్లో nowadays. In order to get digital views, we can do anything. But మీకు యూజ్ అయ్యే చేస్తే that will be fruitful thing, right? Okay. Anyway, let's see. A 400 by 200 volt 50 Hz transformer operates at a flux density of 1.2 Tesla when excited from its HV side. For this transformer, linear dimensions of the core are doubled while the number of turns are halved. Okay, on both its HV and LV sides. If this transformer is now connected to 800 volt 50 Hz on its HV side, then what would be the new flux density? Okay, so it's an important question. There are two cases in this problem. You see, in the first case, transformer voltage was 400. Okay, I'll use a different color. Transformer voltage was 400, frequency was 50 Hz, flux density was 1.2 Tesla. Transformer is excited from HV side. HV side అంటే 400 volt. అయితే ఇప్పుడు ఏం చేశారు? For this transformer, linear dimensions of the core are doubled. అంటే ట్రాన్స్ఫార్మర్ కన్స్ట్రక్షన్ మారిపోయింది. ఓకేనా? అన్ని లీనియర్ డైమెన్షన్స్ కూడా డబుల్ అయిపోయాయి. While the number of turns are halved. Number of turns ఏమో హాఫ్ అయ్యాయి on both sides, HV side and LV side. ఆ తర్వాత ఏం చేశారు? Now this transformer is connected to 800 volt 50 Hz on HV side again. What is the new flux density? ఓకేనా? దీన్ని మీరు సింపుల్ గా EMF ఈక్వేషన్ ని యూస్ చేసి ఆన్సర్ చేయొచ్చు. వాట్ ఈస్ వోల్టేజ్ ఈక్వేషన్ ఇన్ ట్రాన్స్ఫార్మర్? 4.44 BM క్రాస్ సెక్షనల్ ఏరియా ఫ్రీక్వెన్సీ ఇంటూ నెంబర్ ఆఫ్ టర్న్స్. అవునా కదా? అయితే మీకు ఫస్ట్ కేసులో ఫ్రీక్వెన్సీ 50, సెకండ్ కేసులో కూడా ఫ్రీక్వెన్సీ 50. సో ఫ్రీక్వెన్సీ వాస్ కాన్స్టెంట్, isn't it? So voltage will be now directly proportional to flux density, area and number of turns. ఓకేనా? ఇది డైరెక్ట్ ప్రపోర్షనాలిటీ కాబట్టి నేను ఎలా రాయొచ్చండి? ఫస్ట్ కేసు వోల్టేజ్ బై సెకండ్ కేసు వోల్టేజ్ ఈజ్ ఈక్వల్ టు ఫస్ట్ కేసు డెన్సిటీ బై సెకండ్ కేసు డెన్సిటీ, ఫస్ట్ కేసు ఏరియా బై సెకండ్ కేసు ఏరియా, ఫస్ట్ కేసు నెంబర్ ఆఫ్ టర్న్స్ బై సెకండ్ కేసు నెంబర్ ఆఫ్ టర్న్స్. ఓకే, నౌ వాట్ ఈస్ ద వోల్టేజ్ ఇన్ ద ఫస్ట్ కేస్ అండి? 400. సెకండ్ కేసులో ఎంత వోల్టేజ్ యూస్ చేసాం? 800. ఫస్ట్ కేసులో డెన్సిటీ 1.2 టెస్లా, సెకండ్ కేసులో డెన్సిటీ మనం ఫైండ్ అవుట్ చేయాలి. ఇప్పుడు ఏరియా దగ్గర మెయిన్ పాయింట్ వస్తుంది. ఫస్ట్ కేస్ ఏరియా ఈజ్ అస్యూమ్డ్ టు బి A1. నౌ కమింగ్ టు ద సెకండ్ కేస్, వాట్ హ్యాపెన్స్ టు ఏరియా? సో కామన్ మిస్టేక్ ఈస్, యాజ్ it was mentioned, linear dimensions are doubled. Don't say area is doubled. Okay, what is the unit for area? Meter square. When I say linear dimensions are doubled, every meter becomes 2 meters. Then meter square will increase by 4 times. Okay, so therefore second case area is 4 times of first case area. First case number of turns are n1, second case number of turns becomes half, right? Half of n1. Now A1 will cancel, N1 will cancel. You can easily find out the new density. ఎంత వస్తుందండి ఆన్సర్? Yes, what is the new density? Come on. Yes, keep answering. It will be more engaging, right? Yes, the new density will be once again 1.2 Tesla. Yes, correct answer. B2 is once again 1.2 Tesla. That means density is not changing. Density is not changing. Okay. Yes. This is a question you can look into. Sometimes మీకు ఇంకొక మోడిఫికేషన్ కూడా జరగవచ్చు. ఫస్ట్ కేసులో ఫ్రీక్వెన్సీ 50 యూస్ చేసి సెకండ్ కేసులో ఫ్రీక్వెన్సీ 60 చేయొచ్చు. ఓకే, ఫ్రీక్వెన్సీ మే ఆల్సో చేంజ్. అప్పుడు ఫ్రీక్వెన్సీ కూడా వేరియబుల్ అవుతుందండి. ఓకేనా? సో ఎనీథింగ్ మే హ్యాపెన్, రైట్? ఆల్ రైట్. Yeah, 1.2 Tesla. Okay, one more question. This is also from PS Bimbra Textbook. Just go through this question. No issues, right? Hope the session was running smoothly. Yes. Okay. Now let's move through another question. In an ideal transformer, if K is some constant, then supply voltage V in terms of magnetizing current IM can be expressed as supply voltage V in terms of magnetizing current. First of all, Magnetizing current is an active component or reactive component? Yes. Magnetizing current is a purely reactive component. Reactive component. And it will be represented using an inductive reactance across the supply voltage source, right? So this is the supply voltage V1. This is the magnetizing reactance Xm, and this is magnetizing current Im. Okay, it's a reactive component. Now you can apply KVL equation here. So what is that? V1 is equal to magnetizing current I mu into Jxm. Okay. Now you can further expand J into magnetizing current I mu into, this is inductive reactance, right? If it is inductive reactance, you can write it as 2 pi F into L. Okay, 2 pi F into L. Now in this equation, 2 pi and L are going to be constants, right? And that constant is given as K in the problem. K is some constant, and that some constant is nothing but 2 pi into L. Okay, so therefore the remaining thing, J into I mu into frequency into that constant K. So this is how supply voltage is in terms of magnetizing current. So therefore, what is the correct answer here? J into K into frequency into magnetizing current. Okay, what if I ask you magnetizing current in terms of voltage? For example, I want magnetizing current in terms of voltage. Then magnetizing current will be equal to voltage divided by J into frequency into K. J will go to the numerator, minus J V by F into K. So this is magnetizing current in terms of voltage. Okay, yes, right. Okay, that is K, constant K. Remaining quantities are variable. You can change frequency, then magnetizing current will also change. These are variables. Inductance and 2 pi were constants once the construction is completed. Okay. Now another simple question, okay, from transformer no load. This is all no load behavior of a transformer. Okay, yes, read the problem. In a transformer, exciting current is made up of two components. Exciting current means what? No load current. No load current is also known as excitation current. Okay, excitation current. So excitation current is component of made up of two components, magnetizing current and core loss current. Yes, we know. No load current is a combination of magnetizing current and loss component current, represented with the letter IW or IC, whatever word you use. Now we all know that this magnetizing current is a purely reactive component. This is a purely reactive component, and this loss component current is purely an active component. This is purely an active component. Okay, currents also, see, magnitudes also, if you think, reactive component will be 4 to 5% of the rated current. Loss component current is 1 to 2% of the rated current. And if we draw the phasor diagram of this particular transformer, if you remember phasor diagram, we will take main flux as reference. Then just a moment. Then induced EMF is always lagging this flux by 90 degrees. Supply voltage will be exactly opposite to that, right? Okay. So now where will be the magnetizing current? Magnetizing current is purely reactive and it will lag the voltage by 90 degrees. Okay. It will lag the voltage by 90. That's why it is like an inductive current component. అంతే కదండి, ఇండక్టర్లో మాత్రమే కరెంట్ అనేది వోల్టేజ్కి 90 degrees లాగింగ్లో ఉంటుంది. అండ్ లాస్ కాంపోనెంట్ కరెంట్ ఈస్ ప్యూర్లీ యాక్టివ్, ఇట్ విల్ బి ఇన్ ఫేజ్ విత్ వోల్టేజ్. ఓకే, నౌ ఇఫ్ యూ యాడ్ బోత్ ఆఫ్ దెమ్, then we will get the resultant no load current represented with I0. Okay, I0, it is the no load current, okay, of a transformer, and this is known as no load power factor phi naught. ఓకేనా, ఈ పర్టికులర్ ప్రాబ్లంకి ఈ రెండు ఇన్ఫర్మేషన్స్ తెలిస్తే చాలు. నేను మిగతా ఇన్ఫర్మేషన్స్ ఎందుకు చెప్తున్నానంటే ప్రాబ్లం మారచ్చు కదా నెక్స్ట్ ఎగ్జామ్లో. ఓకే, సో యూ మే గెట్ ఎ క్వశ్చన్ రిలేటెడ్ టు నో లోడ్ పవర్ ఫ్యాక్టర్. So what is the range of no load power factor? And no load power factor of a transformer is very poor. What is the range? Cos of phi naught is around 0.2 to 0.3 lagging. Okay, it's a poor power factor. Got it? Yes. So finally, the correct answer is magnetizing current is lagging the voltage by 90 degrees, and core loss current, also known as loss component current IW, is in phase with voltage. So therefore, third option is correct. And magnetizing current is inductive component or resistive component? Inductive component. Loss component current is a resistive component because it's an active component, right? Okay. Now, this is an important question. Okay, this was there in many PSU exams also. This question, just to go through it, guys, all of you. Sarvesh ఒక క్వశ్చన్ అడిగాడు, నో లోడ్ పవర్ ఫ్యాక్టర్ ఆఫ్ ఐడియల్ ట్రాన్స్ఫార్మర్ ఎంత అని. ఫస్ట్ ఆఫ్ ఆల్, ఇన్ ఐడియల్ ట్రాన్స్ఫార్మర్ నో లోడ్ కరెంట్ ఈస్ జీరో. No load current is zero, right? If no load current is zero, how do we define power factor? Isn't it? Okay, so no load current is zero. Then without current, you can't define power factor, right? Okay. Anyway, look at this question. A transformer at no load is excited at rated voltage. Now, a cut is made in the transformer yoke so that it creates an air gap. With this, what happens to transformer core flux? Most of you, those who practiced PYQs, you might have come across this question already, and you might have remembered the answer also, okay? But the proof is very important, how this is happening. If a similar model question in a different way, if they asked, you should be able to answer, right? Okay. So now, the point is that we have a transformer core, okay? This is a transformer core, imagine. And this transformer core is wounded with a coil having, let us say, number of turns equal to N. And you are exciting this transformer core with a voltage source V. So immediately what will happen? The transformer will draw a current known as magnetizing current. That magnetizing current will create a flux in the transformer, and that flux will link the coil. Okay, the flux will link the coil so that an EMF will be induced across the transformer winding. Now, according to KVL equation, if the supply voltage V is V, induced EMF is E, both must be equal in magnitude, right? Supply voltage, drop voltage rendu equal untali kadandi, then only KVL equation will be satisfied. Okay, now what happened in the next case? Okay, in the next case what happened? They said an air gap is created. The transformer core is, a cut is made in the transformer core so that there is an air gap created. So what will happen to magnetizing current and flux is the question. Ikkada chudandi, even though air gap is created, supply voltage modified or not modified? Not modified, right? Isn't it? Because supply voltage is coming from the grid. If grid voltage doesn't change, this V is constant. If V is constant, induced EMF E should also be constant. Induced EMF E is also going to be constant. Okay, and who is the reason to create this induced EMF? The flux passing through transformer. The flux which is passing through transformer, that is creating the induced EMF, right or not? And when I say EMF is constant, indirectly this flux is also constant. అంటే మనం ఎయిర్ గ్యాప్ క్రియేట్ చేసినా సరే ఫ్లక్స్ లో ఎలాంటి మార్పు ఉండదు, ఎందుకంటే ఫ్లక్స్ లో మార్పు వస్తే ఈఎంఎఫ్ మారిపోతుందండి. If EMF changes, KVL equation does not satisfy. So therefore, there is no change in the flux. The flux remains constant. So the usual question is, sir, if air gap is created, actually flux has to decrease. That is a usual doubt, okay? But here, flux is a constant value. How flux remains constant? Yes, by drawing more magnetizing current. Imagine the magnetizing current is I mu dash now. It will draw more magnetizing current in order to maintain the same flux. How? You can write the formula for flux. Flux is equal to MMF by reluctance. This current is nothing but magnetizing current. If you cross multiply, N into I mu is equal to flux into reluctance, right? and I'll continue this formula. N into I mu is equal to flux into, what is the formula for reluctance? Length by mu into cross sectional area. Flux the constant kadandi, we already proved flux is constant. Okay, so therefore what is the relation between magnetizing current and permeability of the core? Inversely proportional. Magnetizing current and permeability are inversely proportional. See, the moment you create an air gap, permeability is reducing, right? Permeability reduces because air will have less permeability. If air is having less permeability, magnetizing current will suddenly increase. So definitely the magnetizing current increases in order to maintain same amount of flux. Why I have to maintain same amount of flux? Because the voltage has to be constant. Okay, voltage has to be constant. So therefore the flux remains constant, but magnetizing current will increase. So second option will be the correct answer. Second option will be the correct answer. Okay. గేట్ పీవైక్యూస్ గురించి సెషన్ అడుగుతున్నారండి. మన యూట్యూబ్ ఛానల్లో ఆల్రెడీ ప్రీవియస్ గేట్ క్వశ్చన్స్ ఆల్రెడీ డిస్కస్ చేసాము. ఐ రిక్వెస్ట్ ఆల్ ఆఫ్ యూ ప్లీజ్ గో త్రూ దెమ్. ఓకేనా, ప్రీవియస్ గేట్ క్వశ్చన్స్ మేము గేట్ మ్యారథాన్ సెషన్స్ అని చేస్తూ ఉంటాము. నెంబర్ ఆఫ్ టైమ్స్ గేట్ పీవైక్యూస్ గురించి అన్ని సబ్జెక్ట్స్ ఆల్రెడీ మన యూట్యూబ్ ఛానల్లో ఉన్నాయి. యూ కెన్ గో త్రూ దెమ్. ఓకే, రైట్. ఎనీవే, దట్ ఈస్ ది కరెక్ట్ ఆన్సర్. ఓకే, this is slightly an easier question. Request all of you please read the problem first. Okay, read the question. Okay, if the secondary winding of the ideal transformer shown in the circuit of figure C42 has 40 turns, secondary has 40 turns, the number of turns on the primary winding for maximum power to be transferred to the load. See here guys, assume the number of turns on primary are N1 and I want maximum power to be transferred to this load resistance. Let's say load resistance is RL. Okay, సో ఇక్కడ ఏ థియరం అప్లై చేయాలండి? మాక్సిమం పవర్ ట్రాన్స్ఫర్ చేయాలి అంటే యూ హ్యావ్ టు యూజ్ మాక్సిమం పవర్ ట్రాన్స్ఫర్ థియరం, రైట్? సో మాక్సిమం పవర్ ట్రాన్స్ఫర్ థియరం మీరు యూజ్ చేయాలి అంటే ఫస్ట్ యూ హ్యావ్ టు మేక్ ఎంటైర్ ట్రాన్స్ఫార్మర్ లైక్ ఏ సింగిల్ సర్క్యూట్. therefore transfer this load resistance to source side. Okay, how do you transfer elements from one side to another side? Yes, see, the source voltage is here Vs, source resistance is 8 ohm. Now load resistance is transferred to source side, it will be RL dash. What is the formula for RL dash? We are transferring to source side, therefore it will be N1 by N2 whole square times of RL. అవునా కదా, మనకి నెంబర్ ఆఫ్ టర్న్స్ N1 తెలియదండి. N1 by N2 has 40 turns whole square into load resistance 2. Now you apply maximum power transfer theorem. What is maximum power transfer theorem? Maximum power can be transferred to load if load resistance is equal to source resistance, right? So I can use maximum power transfer theorem according to maximum power transfer theorem, right? Okay, so load resistance must be equal to source resistance. Load resistance ఎంత ఉందండి? N1 by 40 whole square into 2 ohm is equal to source resistance 8 ohm. Therefore N1 by 40 is equal to 2, N1 is equal to 80 turns. Therefore primary winding require 80 turns so that we can transfer maximum power to the load. This is known as impedance matching application. దీన్నే మనం ట్రాన్స్ఫార్మర్ లో ఇంపిడెన్స్ మ్యాచింగ్ అప్లికేషన్ అంటాం. అంటే ఈ 2 ఓం రెసిస్టెన్స్ ని 8 ఓం తో ఈక్వల్ చేసాం మనం, అంతే కదా. లోడ్ రెసిస్టెన్స్ సోర్స్ రెసిస్టెన్స్ ఈక్వల్ అయితేనే మాక్సిమం పవర్ ట్రాన్స్ఫరింగ్ జరుగుతుంది. సో we equated this 2 ohms with 8 ohms, that's why maximum power is transferred with the help of a transformer. So we call it as impedance matching transformer. Okay, impedance matching transformer. All right, Yes. Fine. Now this is a simple question, similar model. A transformer has N1 and N2 turns in primary and secondary windings respectively. Its secondary winding reactance is X2. When referred to primary, what is its value? Okay, na? So మనకి ఏం చెప్పారంటే there is a transformer. Primary has N1 turns. Secondary has N2 turns. Now there is a reactance in the secondary side. Its value was X2 ohm. Okay, ohm అంటే ఏంటండి actual value. Now we are asked to transfer this reactance to primary side. Then what is its value? When any element goes to the primary side, x2 becomes x2 dash. What is its value అండి? మనం ఏ సైడ్ కి వెళ్తున్నామో ఆ నెంబర్ ఆఫ్ టర్న్స్ న్యూమరేటర్ లో ఉండాలి. సో ఇట్ విల్ బి n1/n2 హోల్ స్క్వేర్ ఇంటూ x2. ఓకేనా? సో వీఆర్ మూవింగ్ టు ప్రైమరీ సైడ్. సో n1/n2 హోల్ స్క్వేర్. In a similar manner, if you move from primary to secondary, as you are moving to secondary side, it will be n2/n1 whole square. So therefore, the correct answer is n1/n2 whole square times of x2, right? C. Simple question. Okay. Fine. Yeah. One more question. This is a question from the iron losses in a transformer. Please go through this problem. Yeah. Go through this problem. The hysteresis and eddy current losses of a single phase transformer working on 200 volt, 50 Hz are PH and PE respectively. The percentage decrease in these two losses when operated from 160 volt, 40 Hz. మీరు iron losses in transformer చదివి ఉంటారండి already. So transformer will have two types of iron losses. One is hysteresis loss, another one is eddy current loss. సో అయితే ఈ రెండు ఫార్ములాస్ ని మనం టూ కండిషన్స్ లో చదవాలి. వాట్ ఇఫ్ V/F రేషియో ఈజ్ కాన్స్టెంట్ అండ్ వాట్ ఇఫ్ V/F రేషియో ఈజ్ వేరియబుల్. అయితే మనకి ఇచ్చిన క్వశ్చన్ లో ఇన్ ద ఫస్ట్ కేస్ వోల్టేజ్ వాస్ 200, ఫ్రీక్వెన్సీ వాస్ 50. సో వాట్ ఈస్ V/F రేషియో? సో ద V/F రేషియో V1/F1 ఈజ్ 200/50, దట్ ఈస్ 4. In the second case, V2 was 160, 40. So V2/F2 is equal to 160/40. This is also 4. That means what? V/F ratio was constant. Now, the moment you know V/F ratio is constant, what is the formula for hysteresis loss? Yes, hysteresis loss is directly proportional to frequency. Eddy current loss directly proportional to frequency square. These formulas are valid if V/F ratio was constant. So according to this, first case hysteresis loss by second case hysteresis loss is equal to F1/F2. First case lo frequency entandi 50, second case lo 40. Therefore, the new hysteresis loss is 0.8 times of old hysteresis loss. దీన్ని పర్సెంటేజ్ లో కన్వర్ట్ చేస్తే ఏమవుతుందండి? న్యూ హిస్టెరిసిస్ లాస్ ఈజ్ 80% ఆఫ్ ది ఓల్డ్ హిస్టెరిసిస్ లాస్. దట్ మీన్స్ హిస్టెరిసిస్ లాస్ రెడ్యూసెస్ బై 20%. ఓకే, ఎస్. సిమిలర్లీ ఎడ్డీ కరెంట్ లాస్. Eddy current loss in the first case divided by eddy current loss in the second case is equal to F1/F2 whole square. So first case eddy current frequency 50/40 whole square. So the new eddy current loss will be equal to 0.64 times of the previous eddy current loss. అంటే మీనింగ్ ఏంటండి? న్యూ ఎడ్డీ కరెంట్ లాస్ ఈజ్ 64% of old eddy current loss. That means eddy current loss is reduced by 36%. So hysteresis loss reduces by 20%. Eddy current loss reduces by 36%. That is option B. Okay na? For example, what if V/F ratio was not equal? ఈ క్వశ్చన్ లో V/F ratio కాన్స్టెంట్ గా ఉంది. వాట్ ఇఫ్ V/F ratio was unequal? In case if V/F ratio is not a constant value, అప్పుడు ఫార్ములాస్ ఏంటంటే hysteresis loss will be proportional to V⁻1.6 into F⁻−0.6. Eddy current loss is proportional to V square. అయితే ఈ v పవర్ 1.6 f పవర్ -0.6 కొంచెం డిఫికల్ట్ క్యాలిక్యులేషన్స్లో. మీకు క్యాలిక్యులేటర్ అలౌడ్ ఉంది కాబట్టి ఓకే. ఒకవేళ క్యాలిక్యులేటర్ అలౌడ్ లేకపోతే ఒక అప్రాక్సిమేట్ అనాలిసిస్ తీసుకోవచ్చు. ఇక్కడ 1.6 is near to 2, right? Therefore, you can take it as v square. -0.6 is near to -1. So, approximately it is v square by f. This is approximate formula for hysteresis loss, ఎడ్డీ కరెంట్ లాస్. ఇలా ఈ ఫార్ములాస్ యూజ్ చేస్తే ఏమవుతుందంటే ఆన్సర్ క్విక్గా వచ్చే అవకాశాలు ఉంటాయి. మీకు ఎగ్జాక్ట్ ఆన్సర్ కావాలంటే ఈ ఫార్ములా యూజ్ చేయాలి. ఓకేనా? సో దీస్ ఆర్ ది ఫార్ములాస్ యూ మస్ట్ యూజ్ ఇఫ్ v by f రేషియో వాస్ అన్ఈక్వల్. ఇంకొకటి గుర్తుపెట్టుకోండి, దీస్ ఫార్ములాస్ ఆర్ వ్యాలిడ్ ఓన్లీ ఇఫ్ కన్స్ట్రక్షన్ ఈస్ కంప్లీటెడ్. కన్స్ట్రక్షన్ ఈస్ కంప్లీటెడ్. కన్స్ట్రక్షన్ కంప్లీట్ అయిన ట్రాన్స్ఫార్మర్స్ కి మాత్రమే ఈ ఫార్ములాస్ వ్యాలిడ్. ఒకవేళ నేను ఫిజికల్ డైమెన్షన్స్ చేంజ్ చేసిన, ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఐ సే ఫిజికల్ డైమెన్షన్స్ ఆర్ డబుల్డ్, ఓకే, ఆర్ నెంబర్ ఆఫ్ టర్న్స్ ఆర్ హాఫ్డ్, ఇలా కన్స్ట్రక్షన్ లో ఏదైనా డిస్టర్బెన్స్ చేస్తే ఈ ఫార్ములాస్ వ్యాలిడ్ కాదు. దెన్ యూ హ్యావ్ టు యూజ్ ఒరిజినల్ ఫార్ములాస్ ఆఫ్ హిస్టెరిసిస్ అండ్ ఎడ్డీ కరెంట్ లాస్. స్టెయిన్ మిడ్ ఈక్వేషన్ లో చదువుతాం కదా, అవి యూజ్ చేయాలి. ఓకే, ఎస్. మీకు ఏడబ్ల్యూ లెవెల్ ఎగ్జామ్స్ లో అంత డెప్త్ గా వెళ్ళకపోవచ్చు. సో నార్మల్లీ దీస్ ఆర్ ది ఫార్ములాస్ వీ విల్ యూస్. ఓకే, ఫైన్. Let's move to another question. For a single phase transformer, RE is the total equivalent resistance, XE is the total equivalent leakage reactance, PC is the core loss. Now the question is the load current at which maximum efficiency occurs is. This is an easy question. See, they are asking about condition for maximum efficiency. We all know that at maximum efficiency, what is the condition? At what load maximum efficiency will generally happen? Yes, maximum efficiency will happen if copper loss value is equal to iron loss. Okay na? Copper loss value is equal to iron loss. ఈ కండిషన్ సాటిస్ఫై అయితే ఖచ్చితంగా maximum efficiency అనేది క్రియేట్ అవుతుంది. And from this condition you can separate current. It will become square root of iron loss divided by resistance. This is what they are asking. What is the current at which maximum efficiency will be produced? Okay, square root of iron loss divided by resistance. Okay, so this is the correct answer, right? Remember, ee root lo resistance kuda cover avutundi. Okay na? Square root of iron loss divided by resistance. Okay, so that is the current at which maximum efficiency will be produced. Okay, okay, okay. Look at this question. This is important, Andy. Right, answer this. Just read the problem first, everybody. For a second, just read the problem. Yeah, I appreciate most of you are actively participating in the discussion. Fine. Okay, guys, just read the problem. Meeku, yeah, frequency of the supply voltage to a transformer at no load increased, but the supply voltage is held constant. With this, what will happen to eddy current loss and what will happen to hysteresis loss? What happens to magnetizing current and core loss current component? ఇవన్నీ కూడా అడిగారు. ఓకే, ఎస్. Frequency of the supply voltage of a transformer at no load is increased, but the supply voltage is held constant. So clear ga frequency increase చేశారు, voltage ఏమో కాన్స్టెంట్ గా పెట్టారు. ఓకే, voltage is constant, frequency increases. ఓకే, అదే కదండి ఇచ్చిన క్వశ్చన్. Frequency is increased, voltage is constant. ఓకే, V by F రేషియో అన్ఈక్వల్. ఓకేనా, అంతే కదా. వోల్టేజ్ కాన్స్టెంట్, ఫ్రీక్వెన్సీ ఇంక్రీజ్ అయిందంటే V by F రేషియో అన్ఈక్వల్. V by F రేషియో అన్ఈక్వల్ అయినప్పుడు ఇప్పుడే మనం డెరైవ్ చేసాం. వాట్ ఈస్ ద ఫార్ములా ఫర్ హిస్టెరిసిస్ లాస్ అండి? ఇట్ విల్ బి ప్రపోర్షనల్ టు V square by F. వోల్టేజ్ ఏమో కాన్స్టెంట్, ఫ్రీక్వెన్సీ ఏమో ఇంక్రీజ్ చేశారు అంటే హిస్టెరిసిస్ లాస్ ఏమవుతుంది, డిక్రీజెస్. హిస్టెరిసిస్ లాస్ డిక్రీజెస్. వాట్ అబౌట్ ఎడ్డీ కరెంట్ లాస్ ఫార్ములా? ఎడ్డీ కరెంట్ లాస్ ఈజ్ ప్రపోర్షనల్ టు వి స్క్వేర్. నేను మళ్ళీ రాయట్లేదు ఆ ఫార్ములాస్, జస్ట్ నౌ వి డిస్కస్ దట్, రైట్? హియర్ యూ హ్యావ్. So this is, if V by F ratio is unequal, approximate formula for hysteresis loss and eddy current loss. Okay na? Mari voltage constant kada, eddy current loss is constant. Eddy current loss is constant. So first statement chudandi, eddy current loss remains constant, okay. Hysteresis loss increases is wrong. Eddy current loss remains constant, okay. Hysteresis loss decreases, this is correct. Second statement ఖచ్చితంగా correct అండి. మరి ఇసి హిస్టెరిసిస్ లాస్ డిక్రీజ్ అయింది, ఎడ్డీ కరెంట్ లాస్ ఏమో కాన్స్టెంట్ గా ఉంది. అలాంటప్పుడు ఓవరాల్ గా ఐరన్ లాస్ ఏమవుతుందండి? ఐరన్ లాస్ ఈజ్ అ సమ్ ఆఫ్ హిస్టెరిసిస్ లాస్ ప్లస్ ఎడ్డీ కరెంట్ లాస్. హిస్టెరిసిస్ లాస్ డిక్రీజెస్, ఎడ్డీ కరెంట్ లాస్ కాన్స్టెంట్. సో కెన్ ఐ సే ఐరన్ లాస్ డిక్రీజెస్? ఐరన్ లాస్ డిక్రీజెస్. మరి ఐరన్ లాస్ డిక్రీజ్ అయితే వాట్ హ్యాపెన్స్ టు లాస్ కాంపోనెంట్ కరెంట్? ఇక్కడే మీకు ఐరన్ లాస్ కి లాస్ కాంపోనెంట్ కరెంట్ కి మధ్య ఉన్న రిలేషన్ ఇంపార్టెంట్. వాట్ ఈస్ అ ఫార్ములా? We all know iron loss is equal to voltage into IW. That IW is known as loss component current. And it is clearly mentioned voltage is constant. Therefore, iron loss is directly proportional to loss component current. What happened to iron loss? Decreases, right? Therefore, loss component current also decreases. Loss component current also decreases. Okay na? So see, core loss current decreases. This is fine. This is correct. But what happens to magnetizing current? This is answer cheyali. What happens to magnetizing current? Magnetizing current is an active component or reactive component? It's reactive component, right? So what is the formula? Magnetizing current is equal to voltage by magnetizing reactance. Already checked kada. So it is represented using an inductive reactance known as magnetizing reactance. So magnetizing current is equal to voltage by reactance. How can you write a formula for reactance? Reactance is equal to 2 pi FL. In the given question, voltage is constant. What happens to frequency? Increases. But frequency increase ayindante the denominator increases, so magnetizing current decreases. Magnetizing current decreases. Okay na? So magnetizing current decrease ante third statement was wrong. I think fourth statement was correct. Both magnetizing current and core loss currents decreases. Therefore, what are the correct statements? 2 and 4 are the correct statements. 2 and 4 are the correct statements, right? So the moment you see iron loss formula, the first formula that should strike your brain, iron loss is equal to voltage into IW. Got it? Yes. Okay. Fine. Now let's move to the next problem. A 4 kVA 400 by 200 volt single phase transformer has leakage impedance of 0.02 plus J 0.04 per unit. What is the leakage impedance in ohm when referred to HV side? మీకు ఇక్కడ ఏం చేశారంటే per unit impedance was given. We are asked to find out actual impedance referred to HV side. So what is the relation? Okay, how do you find out actual impedance if per unit impedance was given? We know the formula, right? Per unit impedance is always equal to actual impedance divided by base impedance. From this, the actual impedance will be equal to per unit impedance multiplied by base impedance, right? Okay, what is the formula for base impedance? We need not to discuss the proof of the formula, we can directly write down. Yes, base impedance is equal to base voltage square divided by volt ampere base. So now on which side we want this impedance? We want this impedance to be calculated on which side? HV side. HV side means what is the voltage? 400. Okay, so therefore it is 400 square divided by what is the volt ampere base? 4 kVA. This will be 40 ohm, correct? Now replace that base impedance here. So per unit impedance will be Remember, per unit value will be same on both sides. Okay, yes, 0.02 plus j 0.04 into base impedance 40. So I think it will be 0.8 plus j 1.6 ohm, referred to which side? HV side. For example, if I want the same impedance referred to LV side means I have to use a voltage 200. Got it? Yes. So it's a simple question. Okay. So here in this question, per unit impedance was given. Actual impedance is asked. Sometimes actual impedance may be given. We may be asked to find out per unit impedance. Okay. Both you should be able to answer. Okay. Now, మీరు ఫ్రాక్షన్స్ దగ్గర జాగ్రత్తగా ఉండాలండి. 0.8, 0.08, డోంట్ డూ సిల్లీ మిస్టేక్స్. ఓకే, ఒకవేళ నేనేమైనా మిస్టేక్ చేస్తే చెప్పండి. ఓకేనా? ఎస్, రైట్. సో దిస్ ఈజ్ అబౌట్ కన్వర్టింగ్ పర్ యూనిట్ ఇంపిడెన్సెస్ టు యాక్చువల్ ఇంపిడెన్స్ వాల్యూ, రైట్? ఓకే, నౌ go through the next question. This is an important question అండి. కొంచెం లాజికల్గా ఆలోచిస్తే మీకు ఆన్సర్ వచ్చేస్తుంది. ప్లీజ్ థింక్ లాజికల్లీ. ఓకే, hope it is visible to you, right? Okay, for the system shown in figure C.44, the phase relation of current I with respect to voltage VAB is current I with respect to voltage VAB. VAB is nothing but supply voltage. Current I is on the secondary side. What is the relation between these two? You must be very, very careful about the dot polarities mentioned on the transformer, and the load is purely inductive. The load is purely inductive, right? Yes, please understand this is a transformer. In a transformer is a negatively magnetic coupled circuit, right? It's a negative magnetic coupling circuit. Because it is a negative magnetic coupling circuit, primary current I1 will always enter the dot. Secondary current I2 will always leave the dot. Secondary lo ikkada dot undi chudandi. So secondary current will leave from here. But కానీ మనకు క్వశ్చన్ లో అడిగింది ఈ కరెంట్ I. So what is the relation between I2 and I if I ask you? Is it not I and I2 both are opposite to each other? So I is nothing but minus I2. All right. Now point is, what is the type of the load connected on the secondary side? Purely inductive load. Because it is a purely inductive load, current I2 will lag the voltage by 90 degrees, right? So therefore I2 will be equal to magnitude of I2 at an angle minus 90 degrees ampere. If you know this is I2, then what is I1, guys? In a transformer, primary current I1 is equal to K times of I2 kadandi. So therefore it will be K times of what is I2? Magnitude of I2 at an angle minus 90 degrees. Okay. Now what is I? I is nothing but minus I2, right? So therefore K into in place of I2 you can write minus I. It is K into K into minus I can write. Okay now. So if I2 is at an angle minus 90, I will be at an angle plus 90. Are you understanding that? Right. I better do this. Okay. So this is, guys, I1. Okay. So I1 is at an angle minus 90 with respect to I2, but I2 and I both are opposite, right? So therefore I1 will be equal to K times of I at an angle plus 90. ఇది ప్లస్ 90 ఎందుకు అయిందంటే, సి బోత్ ఆర్ ఆపోజిట్ టు ఈచ్ అదర్. I and I2 both are opposite to each other. That minus means you have to add extra 180 degrees. So minus 90 changes to plus 90. So therefore I1 is equal to I at an angle plus 90 degrees. Plus 90 degrees means it will be option B. Okay. Right or not? That is I1. Clear? So what is the question they are asking? I need current I with respect to voltage VAB. I need current I. మనకు కావాల్సింది I1 కాదండి. We want I. What is I is equal to minus I2. Okay. I is equal to minus I2. What is I2? I2 is equal to I1 by K. So minus of what is I1 we got? Okay, I1 is equal to K times of I2 at an angle minus 90. So ఇప్పుడు మీరు దీనికి phasor diagram draw చేస్తే clear idea వచ్చేస్తుంది. Rather than doing all these things, you can do phasor diagram. So for example, if you draw a phasor diagram, take supply voltage VAB here. VAB. What is I1 we got? Okay, I1 is equal to I at an angle plus 90. Okay, plus 90 here. This is I1. This is I. Okay, right. That is VAB. VAB is the supply voltage. Yes. I1 is at an angle plus 90. I1 is I. In fact, it is K into I. Not exactly I. It is K into I. This is K into I. K into I at an angle plus 90. Right. Okay. Simple గా ఆన్సర్ చేయొచ్చు. ఇండక్టివ్ లోడ్ కాబట్టి యూజువల్ గా ఇండక్టివ్ కరెంట్ విల్ బి అట్ అన్ యాంగిల్ మైనస్ 90 కదా. కానీ మీకు I అనేది ఆపోజిట్ డైరెక్షన్ లో ఉంది. సో మైనస్ 90 ప్లస్ 90 అవుతుంది. ఒకవేళ అదే I కరెంట్ ఇఫ్ ఇట్ ఈస్ లీవింగ్ ద డాట్ ఇట్ వుడ్ హావ్ బీన్ మైనస్ 90. ఓకే, but it is opposite, that's why it's plus 90. Okay, next one more typical question. Okay, one more typical question, go through this. Two transformers X and Y with identical ratings and dimensions have 0.8 mm and 1.2 mm thickness laminations respectively. If RC and XM are the magnetizing branch parameters in the equivalent circuit, then we have to compare RC and XM values of both transformers X and Y. Okay, both transformers X and Y. So please understand, there are two transformers X and Y. Both are identical ratings. Identical ratings in the sense voltage rating is same, current rating is same, power rating is same, everything is same except one difference. What is that one difference? Lamination thickness is different. One transformer is having a lamination thickness 0.8 mm. Another transformer is having 1.2 mm. That is the only difference. Except that everything is the same. Then compare core loss resistance RC and magnetizing reactance XM of these two transformers. Okay, see, generally lamination thickness will represent the magnitude of eddy current loss, right? What is the relation between eddy current loss and lamination thickness? We all know that eddy current loss is directly proportional to square of the lamination thickness. It will be directly proportional to square of the lamination thickness. అంటే మీనింగ్ ఏంటండి? ఇఫ్ లామినేషన్ థిక్నెస్ ఈజ్ లెస్, ఎడ్డీ కరెంట్ లాస్ ఈజ్ లెస్. లామినేషన్ థిక్నెస్ ఈజ్ మోర్, ఎడ్డీ కరెంట్ లాస్ ఈజ్ మోర్. నౌ లెట్ us compare the two transformers we have, X and Y. In transformer X, what is the lamination thickness? 0.8 mm. Transformer Y, 1.2 mm. Therefore, lamination thickness is less in transformer X. As a lamination thickness is less, eddy current loss is less. Okay, I better use a symbol for more clarity. So eddy current loss is less compared to transformer Y. Transformer X has less eddy current loss compared to transformer Y. And we all know that eddy current loss is a part of which loss? Iron loss, right? Less eddy current loss indicates less iron loss. Less iron loss. And in transformer, iron loss is represented using a resistance known as RC, core loss resistance. If you go through the equivalent circuit of transformer, this is a core loss resistance, this is the voltage. What is the formula for iron loss in terms of RC? V square by RC. This is iron loss formula. Therefore, can I say iron loss and RC both are inversely proportional? So less iron loss means more RC, more iron loss is less RC. So this is having less iron loss, therefore higher RC value compared to transformer Y. This is the first answer. RC of a transformer X is more than RC of a transformer Y. What is one more parameter we have to compare? Not only RC, we have to compare XM also, magnetizing reactance. So what is the formula for magnetizing reactance? Magnetizing reactance is equal to 2 pi F into L. And what is the formula for L here? L is inductance of the transformer winding. What is the formula for inductance? N square by R, where R is the reluctance, N is the number of turns. Again, what is the formula for reluctance? Reluctance is equal to length of the core by mu into cross-sectional area. So according to the given question, there is only one difference between two transformers, that is the lamination thickness only. Except that everything is the same. Length is the same, area is the same. That means reluctance is the same in both transformers. Reluctance is the same. Reluctance is the same, number of turns are same. Inductance is also same in both transformers. ఏమీ మారలేదండి, లామినేషన్ థిక్నెస్ తప్ప ఏ అదర్ పారామీటర్ కూడా మారలేదు. ఓకే, ఇఫ్ ఇండక్టెన్స్ ఈజ్ సేమ్, reactance is also going to be same. Therefore, the reactance is also same in both transformers. The reactance is also same in both transformers. So finally, what is the correct answer? RC of first transformer is greater than RC of that second transformer. Okay, XM values are likely to be equal. So what is the correct answer? XM values of both transformers are likely to be equal, but RC of X is likely to be higher than RC of Y. So therefore, second option will be the correct answer. Second option will be the correct answer. Okay, fine. Second option will be the correct answer. Okay. Now, let's discuss few questions related to testing of the transformer also. It will be a long session, and today will be a long session. I will try to cover all the 4 types of machines. You must have patience. Okay, right. Following statements are made regarding the short circuit test on a single phase transformer. The question is about short circuit test. I have 7 statements there, and you need to answer the correct answer here. What are the correct statements? 7 statements unnai. What are the correct statements? Generally, short circuit test is performed from which side? HV side, right? It will be performed from HV side, and it will be short circuited on LV side. LV side it will be shorted. HV side the source voltage will be connected. This is VSC. Current is ISC. So therefore, HV side short circuited is wrong. Okay. And also during a short circuit test, voltage is very small to circulate rated current, right or not? Ade open circuit aithe voltage is rated value, current is very small. So it is performed at rated current is correct answer. And it will give core loss or copper loss. And yes, short circuit test will give copper loss, not core loss. It is to find out copper loss of the transformer. Okay, LV side is shorted, that is correct. LV side is shorted, that is correct. It is performed at rated voltage is wrong. Yes, we will do it at very small voltage. Voltage is very small. It gives ohmic loss on the side instruments are connected. Yes, ohmic loss it will give. But on which side it will be measured? And it will be measured on the primary side, right? It helps in the calculation of voltage regulation. Yes, endukandi voltage regulation formula enti? Voltage regulation is equal to R per unit cos phi 2 plus or minus X per unit sin phi 2. So to find out voltage regulation, I need per unit resistance and per unit reactance. Both are series branch parameters. మనకి ట్రాన్స్ఫార్మర్ లో షంట్ బ్రాంచ్ ఉంటుంది, సిరీస్ బ్రాంచ్ ఉంటుంది. ఈ రెసిస్టెన్స్ అండ్ రియాక్టెన్స్ అనేవి సిరీస్ బ్రాంచ్ అండి. And yes, using a short circuit test, we will find series branch parameters. Series branch parameters can be calculated. అదే ఓపెన్ సర్క్యూట్ అయితే we will calculate shunt branch parameters. అంటే ఇప్పుడు కరెక్ట్ ఆన్సర్స్ ఏంటండి 2467. 2467 అయితే కరెక్ట్, మనకి అదే ఆప్షన్ లేదు. అంటే 247 ఉంది, అంటే సిక్స్త్ స్టేట్మెంట్ మనం ఎక్కడ మిస్టేక్ చేసాం. చూడండి, సిక్స్త్ స్టేట్మెంట్లో ఏమి ఇచ్చారు, ఇట్ గివ్స్ ఓమిక్ లాస్ ఆన్ ద సైడ్ వేర్ ఇన్స్ట్రుమెంట్స్ ఆర్. ఇది రాంగ్ అండి, రాంగ్. నేను మిస్టేక్ చేశాను ఇక్కడ. యాక్చువల్గా మనకి టోటల్ ఓమిక్ లాస్ వస్తుందా లేకపోతే ఓన్లీ ప్రైమరీ ఓమిక్ లాస్ వస్తుందండి? ఎస్, టోటల్ ఓమిక్ లాస్ కెన్ బి ఐడెంటిఫైడ్. కానీ ఈ సిక్స్త్ స్టేట్మెంట్ లో ఏమి ఇచ్చాడంటే ఇట్ గివ్స్ ఓమిక్ లాస్ ఆన్ ద సైడ్ వేర్ ఇన్స్ట్రుమెంట్స్ ఆర్ కనెక్టెడ్. మనం ఇన్స్ట్రుమెంట్స్ ప్రైమరీలో కనెక్ట్ చేస్తాం కదా, ప్రైమరీ ఓమిక్ లాస్ మాత్రమే క్యాలిక్యులేట్ అవుతుంది అని ఇచ్చాడు. ఎస్, ఇట్ ఈస్ రాంగ్. It will measure the entire copper loss, not only on the primary side. Okay, so therefore correct answers are 247. Okay, the last option is correct. 247 is the correct answer. Okay, right, 247 is the correct answer. Fine. ఇదే క్వశ్చన్ నేను ఓపెన్ సర్క్యూట్ టెస్ట్ కూడా ఇచ్చాను అనుకోండి. ఓపెన్ సర్క్యూట్ టెస్ట్ అంటే ఏంటి? వోల్టేజ్ ఈజ్ రేటెడ్ వాల్యూ, current is very small, and OC test is used to determine core losses, and shunt branch parameters can be identified. Exact opposite. Can I find voltage regulation using OC test? No, we cannot calculate voltage regulation using OC test. So to find out voltage regulation, we need SC test. Okay, we need SC test. Okay, right, fine. Now let's go through one more question. In a transformer, RE2 plus JXE2 are the equivalent leakage impedance ZE2. Its maximum voltage regulation is equal to. Maximum voltage regulation adigarandi. So what is the condition for maximum voltage regulation? Condition for maximum voltage regulation. ఇదే పాయింట్ దగ్గర కండిషన్ ఫర్ జీరో వోల్టేజ్ రెగ్యులేషన్ చదవడానికి కూడా ట్రై చేయండి. ఓకేనా? ఎస్, maximum voltage regulation will be observed only for lagging power factor load, and the condition is load power factor is equal to R by Z. R by Z lagging, where R is the resistance of the transformer winding, Z is the impedance of the transformer winding. Okay, now this is conditional. Okay, and what is the magnitude of the maximum regulation? Magnitude of maximum voltage regulation. Yes, voltage regulation maximum value is equal to per unit impedance or percentage impedance. Okay, na? Just a moment. Per unit impedance or percentage impedance. Okay guys, so what is the final answer for this question? Yes, the answer is, yeah, magnitude of the impedance, maximum voltage regulation is Z per unit, and it will happen at a power factor where cos phi 2 is R by Z lagging. R by Z lagging. ఇదే మీకు జీరో వోల్టేజ్ రెగ్యులేషన్ కండిషన్ కూడా ఒకటేసారి చదవడానికి గుర్తు చేసుకోవడానికి ట్రై చేయండి. జీరో వోల్టేజ్ రెగ్యులేషన్ విల్ హ్యాపెన్ ఫర్ లీడింగ్ పవర్ ఫ్యాక్టర్ అండ్ వాట్ ఈస్ ద కండిషన్? ఎక్స్ బై జెడ్ లీడింగ్ అండి. ఎక్స్ బై జెడ్ లీడింగ్. ఓకే, ఎక్స్ బై జెడ్ లీడింగ్. రైట్. ఓకే, నౌ లెట్స్ గో త్రూ వన్ మోర్ క్వశ్చన్. ప్లీజ్ గో త్రూ దిస్ ప్రాబ్లమ్. The voltage regulation of a transformer at full load and 0.8 power factor lagging is 2.5%. What is the voltage regulation at full load 0.8 power factor leading will be? This is important problem. Okay, 0.8 lagging power factor దగ్గర voltage regulation 2.5% ఉంటే 0.8 లీడింగ్ పవర్ ఫ్యాక్టర్ దగ్గర వోల్టేజ్ రెగ్యులేషన్ ఎంత ఉంటుంది అని మనకి క్వశ్చన్ ఇవ్వడం జరిగింది. ఓకేనా? ఎస్. 0.8 leading power factor దగ్గర what is the voltage regulation? Yes. Okay, go through it. Now, let's see how to answer this problem. Yes. See, first of all, what is the percentage voltage regulation formula? Percentage voltage regulation is equal to percentage R cos phi 2 plus or minus percentage X sin phi 2. All right or not? Now, ఇనీషియల్గా ఈ ఫార్ములాలో ప్లస్ ఎప్పుడు యూజ్ చేస్తాము, మైనస్ ఎప్పుడు యూజ్ చేస్తామండి? ప్లస్ సైన్ వీ విల్ యూస్ ఫర్ లాగింగ్ పవర్ ఫ్యాక్టర్ లోడ్, మైనస్ సైన్ వీ విల్ యూస్ ఫర్ లీడింగ్ పవర్ ఫ్యాక్టర్ లోడ్. ఎస్ ఆర్ నాట్? ఓకే, నౌ ఇట్ వాస్ క్లియర్లీ మెన్షన్డ్ at 0.8 lagging power factor regulation was 2.5. So voltage regulation was 2.5 at 0.8 lagging అంటే cos phi 2 is 0.8 ప్లస్ సైన్ ఫై 2 ఎంత అండి? కాస్ ఫై 2 0.8 అయితే సైన్ ఫై 2 0.6 అవుతుంది. అవునా కదా? నౌ వాట్ ఈస్ ద ఆన్సర్ వీ హ్యావ్ టు ఫైండ్? వాట్ ఈస్ ద వోల్టేజ్ రెగ్యులేషన్ ఎట్ 0.8 లీడింగ్ పవర్ ఫ్యాక్టర్? వాట్ ఈస్ ద న్యూ రెగ్యులేషన్ ఎట్ 0.8 లీడింగ్ పవర్ ఫ్యాక్టర్? లీడింగ్ అంటే ఏంటంటే మైనస్. లీడింగ్ ఈజ్ నథింగ్ బట్ మైనస్ సైన్. ఓకేనా? నెక్స్ట్ పర్సంటేజ్ ఎక్స్ ఇంటూ 0.6. అయితే ఇప్పుడు మీరు క్లియర్గా చూస్తే దిస్ లుక్స్ లైక్ టూ ఈక్వేషన్స్ బట్ దేర్ ఆర్ త్రీ అన్నోన్స్. అవునా కదా? ఇట్ ఈస్ టూ ఈక్వేషన్స్ బట్ దేర్ ఆర్ త్రీ అన్నోన్స్. వాట్ ఆర్ ద త్రీ అన్నోన్స్? ఆర్ వాల్యూ, ఎక్స్ వాల్యూ అండ్ న్యూ రెగ్యులేషన్. దీస్ ఆర్ ద త్రీ అన్నోన్ వాల్యూస్ బట్ వీ హ్యావ్ ఓన్లీ టూ ఈక్వేషన్స్. మరి టూ ఈక్వేషన్స్ త్రీ అన్నోన్స్ అంటే సాల్వ్ చేయడం పాసిబుల్ కాదు. సో వాట్ వీ నీడ్ టు డూ నౌ? We have to proceed from the options. మనకి 4 ఆప్షన్స్ ఇచ్చారండి, ఏదో ఒక ఆప్షన్ కరెక్ట్ అవ్వాలి, అంతేనా? సో వన్ ఆఫ్ ద ఆప్షన్ మస్ట్ బి ద న్యూ రెగ్యులేషన్, న్యూ పర్సంటేజ్ రెగ్యులేషన్. ఓకేనా? సో ఏం చేస్తారంటే ఫస్ట్ ఆప్షన్ ఏ తీసుకోండి. ద న్యూ అకార్డింగ్ టు ఆప్షన్ ఏ వాట్ ఈస్ ద న్యూ రెగ్యులేషన్? -2.5. ఓకేనా? సో ఇప్పుడు మీరు ఏం చేస్తారంటే ఈ న్యూ రెగ్యులేషన్ ప్లేస్ లో -2.5 సబ్స్టిట్యూట్ చేయండి. -2.5. ఈజ్ ఇట్ లుకింగ్ లైక్ టూ ఈక్వేషన్స్ విత్ టూ అన్నోన్స్? Now solve it. ఈ రెండు ఈక్వేషన్స్ యాడ్ చేస్తే -2.5 ప్లస్ 2.5 క్యాన్సిల్ అయిపోయి 0 వస్తుంది. అండ్ దీస్ టూ విల్ క్యాన్సిల్. యూ విల్ గెట్ 1.6 ఇంటూ పర్సంటేజ్ ఆర్. ఫ్రమ్ దిస్ పర్సంటేజ్ ఆర్ ఈజ్ ఈక్వల్ టు 0. అంటే మీరు ఒకవేళ ఆప్షన్ ఏ కనుక మీ ఆన్సర్ అనుకుంటే ద ట్రాన్స్ఫార్మర్ హ్యాస్ 0 రెసిస్టెన్స్. ఈజ్ ఇట్ ప్రాక్టికల్లీ పాసిబుల్ ఫర్ ఎ ట్రాన్స్ఫార్మర్ టు హ్యావ్ 0 రెసిస్టెన్స్? నో. Every transformer will have a finite resistance. That means option A is a wrong answer. Let's move to option B. If you choose option B as your answer, what is the new regulation? 0. The new regulation must be 0. అప్పుడు ఈక్వేషన్ ఏమవుతుందండి? ఫస్ట్ ఈక్వేషన్ 2.5 is equal to R into 0.8 plus X into 0.6. New regulation is 0. R into 0.8 minus X into 0.6. అగైన్ టూ ఈక్వేషన్స్, టూ అన్నోన్స్, రెండు యాడ్ చేస్తే ఏమవుతుందండి? 2.5 ఈజ్ ఈక్వల్ టు, ఐ హేట్ దిస్ పీపీటీ, రాయడానికి కంఫర్టబుల్గా ఉండదు. సో 2.5 ఈజ్ ఈక్వల్ టు 1.6 ఆర్. ఈ రెండు క్యాన్సిల్ అయిపోతాయి. ఇప్పుడు ఆర్ అనేది 0నా ఫైనైటా? ఎస్, ఆర్ ఈజ్ ఎ ఫైనైట్ వాల్యూ. ఆర్ ఈజ్ ఎ ఫైనైట్ వాల్యూ. ఓకే, సో లెట్ us యూజ్ ఎ క్యాలిక్యులేటర్. Okay, 2.5 by 2.5. 2.5 by 1.6. So R is 1.5625. This is a finite value. ఒకసారి R వచ్చిన తర్వాత X కూడా find out చేయండి. You can also find out X now. Substitute R in only one of the equation. So substitute చేస్తే into 0.8 divided by 0.6. Yes, I am getting X equal to 2.08. ఇప్పుడు చూడండి R వాల్యూ ఫైనైటే, X వాల్యూ కూడా ఫైనైటే, అండ్ ఇట్ ఈస్ ఆల్సో షోయింగ్ దట్ వైండింగ్ రెసిస్టెన్స్ ఈజ్ లెస్ దాన్ రియాక్టెన్స్. ఇట్స్ అ valid point, valid design. Generally we will design a transformer to have a low resistance or high resistance అండి. Yes, low resistance. ఎందుకు రెసిస్టెన్స్ లో ఉండాలి? బికాస్ ఇఫ్ ద రెసిస్టెన్స్ ఈజ్ లో, దెన్ ఓన్లీ కాపర్ లాస్ విల్ బి లెస్ అండ్ ఎఫిషియన్సీ విల్ బి మోర్, రైట్? సో R and X both are finite and R is less than X. Therefore, the second option is a valid design. Second option mostly correct అండి. ఓకే, సెకండ్ ఆప్షన్ ఈజ్ మోస్ట్లీ కరెక్ట్. మీరు అలాగనే కావాలంటే థర్డ్ ఆప్షన్తో కూడా ట్రై చేయొచ్చు. థర్డ్ ఆప్షన్ ట్రై చేస్తే వాట్ ఈస్ ద న్యూ రెగ్యులేషన్? -0.9. ఒకవేళ క్విక్గానే ఫాస్ట్గా ఆన్సర్ చేస్తా చూడండి. నాకు సెకండ్ ఆప్షన్ కరెక్ట్ అని డిసైడ్ అయిపోయాను నేను. ఒకవేళ థర్డ్ ఆప్షన్ తీసుకున్నారనుకోండి, 2.5 is equal to R into 0.8 plus X into 0.6. According to third option, new regulation -0.9. R into 0.8 minus X into 0.6. ఈ రెండు యాడ్ చేస్తే ఇక్కడ ఎంత వస్తుందండి? 1.6, రైట్? ఈజ్ ఈక్వల్ టు 1.6 R. సో దీని నుంచి R ఎంత వస్తుందండి? 1 అవుతుంది. ఓకేనా? R 1 అయితే X ఎంత అవుతుందో ట్రై చేయండి. ఇఫ్ R is 1, what is X value? If R is 1, what is X value? 2.5 minus 0.8 by 0.6. X value is equal to 2.833. Okay, ఇది కూడా valid answer అండి. R is a finite value, X is also a finite value. R is less than X. This is also a valid design. నేను ఎక్కడైనా క్యాలిక్యులేషన్ మిస్టేక్స్ చేస్తే చెప్తూ ఉండండి. ఓకేనా? ఎస్, కరెక్ట్. R is 1. R 1 కదా? 2.5 minus 0.9. Yes, R is 1. If R is 1, yes, X is 2 point. అయితే ఈ రెండు ఆప్షన్స్ కూడా కరెక్ట్ అయ్యే అవకాశాలు ఉన్నాయి. అయితే మీరు ఒకటే చూస్ చేయాలి ఆన్సర్. అలాంటప్పుడు ఏది చూస్ చేస్తారు? ఓకేనా? సో హియర్ యు సీ R is 1.5625. Here R is 1 only. Low resistance is always preferable or high resistance is always preferable అండి. Okay, which is preferable? Low resistance is always preferable or high resistance is always preferable? Low resistance is always preferable. ఎవరో రెగ్యులేషన్ కర్వ్ యూస్ చేస్తే ఈజీ అని అంటున్నారు. ఇట్ ఈస్ ఇంపాసిబుల్ టు ఆన్సర్ దిస్ క్వశ్చన్ యూజింగ్ రెగ్యులేషన్ కర్వ్. ఎస్ ఆర్ నాట్? ఇట్ ఈస్ ఇంపాసిబుల్ అండి. రెగ్యులేషన్ కర్వ్ యూస్ చేసి ఎలా ఆన్సర్ చేస్తారు? ఇఫ్ సంబడి టోల్డ్ యూ దట్ రెగ్యులేషన్ కర్వ్ యూస్ చేసి ఆన్సర్ చేయొచ్చు అంటే దట్స్ ఇంపాసిబుల్. ఓకే, ఎందుకంటే రెగ్యులేషన్ కర్వ్లో మీకు ఏం తెలుసు? ఇలా ఉంటుంది రెగ్యులేషన్ కర్వ్. దిస్ ఈజ్ ఇంపిడెన్స్ Z, దిస్ ఈజ్ రెసిస్టెన్స్ R, దిస్ ఈజ్ మైనస్ రియాక్టెన్స్. ఇదే కదా రెగ్యులేషన్ కర్వ్. ఓకే, మనకి ఇచ్చింది ఏంటి? 2.5% రెగ్యులేషన్ అని ఇచ్చారు. దిస్ ఈజ్ పాజిటివ్ రెగ్యులేషన్, దిస్ ఈజ్ నెగిటివ్ రెగ్యులేషన్, దిస్ ఈజ్ లాగింగ్ పవర్ ఫ్యాక్టర్, దిస్ ఈజ్ లీడింగ్ పవర్ ఫ్యాక్టర్. ఇదే కదా మనకి ఇచ్చింది. 2.5% వోల్టేజ్ రెగ్యులేషన్, ఏదో 0.8 లాగింగ్ అనుకోండి, ఇది 0.8 లాగింగ్ అనుకోండి. దీని దగ్గర 2.5% వోల్టేజ్ రెగ్యులేషన్ ఉంది. మీరు ఇప్పుడు దీని నుంచి ఎలా ఆన్సర్ చేస్తారు? 0.8 లీడింగ్ దగ్గర ఎంత అనేది? యూ కాంట్ ఆన్సర్ ఫ్రమ్ రెగ్యులేషన్ కర్వ్. ఎస్, యూ క్యానాట్ ఆన్సర్ ఫ్రమ్ రెగ్యులేషన్ కర్వ్. ఓకే, సో ఓన్లీ ప్రొసీజర్ ఈస్ గోయింగ్ త్రూ ఆప్షన్స్ అండి. అయితే మనకి B అండ్ C ఆప్షన్స్ రెండింటిలో కూడా వ్యాలిడ్ డిజైన్ ఉంది. కాకపోతే నేను C అనేది ప్రిఫర్ చేస్తాను, ఎందుకంటే రెసిస్టెన్స్ ఈజ్ లో వాల్యూ. రెసిస్టెన్స్ ఈజ్ లో వాల్యూ. ఓకే, యూ కెన్ ట్రై ఆప్షన్ D ఆల్సో. ఆప్షన్ D సాటిస్ఫై కాదండి, యూ కెన్ ట్రై దట్. మీకు రెసిస్టెన్స్ అనేది రియాక్టెన్స్ కన్నా ఎక్కువ వస్తుంది అనమాట. పాజిటివ్ రెగ్యులేషన్ కాబట్టి ఎక్కువ వస్తుంది. సో ఆప్షన్ D అనేది సూటబుల్ కాదు. సో ద కరెక్ట్ ఆన్సర్ ఈజ్ ఆప్షన్ C. C కరెక్ట్ అండి. యాక్చువల్గా ఇది ఒక అంబిగ్యూటీ కైండ్ ఆఫ్ క్వశ్చన్. B కూడా కరెక్ట్ డిజైనే, కాకపోతే మనకేంటి రెసిస్టెన్స్ అనేది యాజ్ లో యాజ్ పాసిబుల్ ఉండాలి కాబట్టి వి చూస్ యునో ఆప్షన్ సి అకార్డింగ్ టు ది సొల్యూషన్. ఓకే, రైట్, ఫైన్. మీకు పిఎస్ బింబ్రాలో డిసడ్వాంటేజ్ ఏంటంటే 3 ఫేజ్ ట్రాన్స్ఫార్మర్స్ మీద క్వశ్చన్స్ లేవు టెక్స్ట్ బుక్ మొత్తం కూడా. Okay, anyway, let's answer this question. This is a question from auto transformer. Read the problem. A 20 kVA 2300 by 230 volt 2 winding transformer is to be used as an auto transformer. Okay, to give 2300 by 2530 volt. What is its rating? Okay na, ఇదేనండి మీరు జనరల్ గా చదువుతారు. ఇట్స్ కన్వర్షన్ ఆఫ్ 2 వైండింగ్ ట్రాన్స్ఫార్మర్ టు ఆటో ట్రాన్స్ఫార్మర్. ఓకే, కన్వర్షన్ ఆఫ్ 2 వైండింగ్ ట్రాన్స్ఫార్మర్ టు ఆటో ట్రాన్స్ఫార్మర్. ఓకేనా, సో 2 వైండింగ్ ట్రాన్స్ఫార్మర్ యూజ్ చేసినప్పుడు ద కేవీఏ రేటింగ్ వాస్ 20 కేవీఏ. ఆటో ట్రాన్స్ఫార్మర్ వచ్చినప్పుడు ఎంత వస్తుంది? ఫస్ట్ ఆఫ్ ఆల్, వాట్ ఆర్ ది ఆటో ట్రాన్స్ఫార్మర్ రేటింగ్స్? For auto transformer, the input voltage was 2300 volt, output voltage was 2530 volt. దీని నుంచి మీరు రేషియో కే ఐడెంటిఫై చేయాలి. వాట్ ఈస్ రేషియో కే ఫార్ములా? ఇట్ ఈస్ ఆల్వేస్ ఈక్వల్ టు ఎల్వి బై హెచ్వి ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్. ఎల్వి బై హెచ్వి ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్. వాట్ ఈస్ ఎల్వి? 2300, హెచ్వి 2530. దిస్ ఈస్ ద వాల్యూ కే. Once you know K value, VA rating of auto transformer formula ఏంటండి? 1 by 1 minus K times of VA rating of 2 winding transformer. Okay, 1 by 1 minus K. So this is 1 by 1 minus what is K? 2300 by 2530 into what is the VA rating of 2 winding transformer? 20 kVA. Now you can answer this question. Okay, now this is the VA rating of auto transformer. Once again, you can use calculator. It's a simple calculation only. Right. So 2530 minus 2300 divided by 2530 into 20 kVA. It will be 220 kVA. 220 kVA is the VA rating of auto transformer. అయితే మనకి 220 kVA రెండు ఆప్షన్స్ ఉన్నాయండి, సి అండ్ డి. అయితే ఈ 220 kVA లో కండక్షన్ పవర్ ఎంత అని అడిగారు. ఆల్రెడీ మీకు ఏం తెలుసండి, ఈ 2 వైండింగ్ ట్రాన్స్ఫార్మర్ యొక్క రేటింగ్ అనేది ఇది ఆల్రెడీ ఇండక్షన్ పవర్. ఎస్ ఆర్ నాట్? దట్ ఈస్ ఇండక్షన్ పవర్. ఇన్ 2 వైండింగ్ ట్రాన్స్ఫార్మర్ పవర్ ఈజ్ ట్రాన్స్ఫర్డ్ ఓన్లీ బికాస్ ఆఫ్ ఇండక్షన్ ప్రాసెస్. మరి 20 kVA ఈజ్ ఇండక్షన్ పవర్ అయినప్పుడు remaining 200 kVA will be the conduction power. The conduction power is equal to 220 minus 20. This will be 200 kVA. లేదంటే ఫార్ములా యూస్ చేయండి. వాట్ ఈస్ ద ఫార్ములా ఫర్ కండక్షన్ పవర్? K times of total power. K times of total power. So therefore the conduction power was 200 kVA. So that is option D. It's a straightforward question. VA rating of auto transformer will be equal to 1 by 1 minus K times of VA rating of 2 winding transformer. Okay. అసలు K అంటే ఏంటి? K is LV by HV of auto transformer. Okay. Right. Yes, you can convert 3 winding transformer also as an auto transformer. Possible. But you cannot use all the 3 windings. We have to use any 2 windings only. If it is core type, shell type అయితే 3 windings use చేయొచ్చు. Right? Okay. Now let us see one more question. Single phase supply of 220 volt, 50 hertz is to be obtained from 400 volt, 50 hertz source. The ratio of weight of conductor material in a 2 winding transformer to that of required in auto transformer. Okay na? మనకేంటంటే ఈ క్వశ్చన్లో 220 50 హెర్ట్జ్ అనే వోల్టేజ్ 400 నుంచి తీసుకురావాలి. సో ద సోర్స్ వోల్టేజ్ వాస్ 400. Source voltage was 400. Okay, right. And I need 220 on the output side. Output voltage was 220. Okay na, ఇది మీరు 2 వైండింగ్ ట్రాన్స్ఫార్మర్ అయినా యూస్ చేయొచ్చు, లేదంటే ఆటో ట్రాన్స్ఫార్మర్ కూడా యూస్ చేయొచ్చు. రైట్, 400 you take the tapping here, this is 220. Step down connection. So now what they are asking, what is the ratio between conductors weight? You know, for a given rating, for the same voltage rating, copper winding weight of auto transformer is always equal to 1 minus k times of copper winding weight of 2 winding transformer. Okay, now the k enti, k is always equal to lv by hv, okay, of copper winding weight of 2 winding transformer. ఇక్కడ LV ఎంత 220, HV ఏమో 400. If you continue, copper winding weight of auto transformer is equal to 1 minus LV 220 by HV 400 into copper winding weight of 2 winding transformer. ఇది చేస్తే ఎంత వస్తుందండి? 1 minus 220 by 400. అంతే కదా, 220 by 400. 400 minus 220 అంటే 180 by 400 times of copper winding weight of 2 winding transformer. ఈ రెండిట్లో క్యాన్సిల్ అయ్యేది 18 by 40 అండి, 9 by 20 times of copper winding weight of 2 winding transformer. This is copper winding weight in auto transformer అండి. అయితే మనకు రేషియో ఏం కావాలి? కండక్టర్ మెటీరియల్ ఇన్ 2 winding transformer to auto transformer. 2 winding by auto transformer కావాలి. అప్పుడు ఏమవుతుంది? కాపర్ వైండింగ్ వెయిట్ ఆఫ్ 2 winding transformer by కాపర్ వైండింగ్ వెయిట్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్. ఈజ్ ఇట్ నాట్ 20 by 9? ఎస్, 20 by 9 ఈజ్ ద కరెక్ట్ ఆన్సర్. 20 by 9 అండి, దట్ ఈస్ ఆప్షన్ ఏ, 20 by 9. అదే ఆటో ట్రాన్స్ఫార్మర్ బై 2 winding ట్రాన్స్ఫార్మర్ అంటే 9 by 20 అవుతుంది ఆన్సర్. 9 by 20 కూడా అవుతుంది. క్లియర్? రైట్, 9 by 20. స్కాట్ కనెక్షన్, ఓపెన్ డెల్టా కనెక్షన్ సిలబస్లో ఉందా లేదా అని అడుగుతున్నారండి. ట్రాన్స్ఫార్మర్ అనే వర్డ్ ఉంది కదా అందులో. స్కాట్ కనెక్షన్ అంటే ట్రాన్స్ఫార్మర్ని యూజ్ చేయాలి, ఓపెన్ డెల్టా అయినా ట్రాన్స్ఫార్మర్ యూజ్ చేయాలి. ట్రాన్స్ఫార్మర్ అనే వర్డ్ ఉంటే సిలబస్లో ఉన్నట్లే, కాకపోతే క్వశ్చన్లు చాలా రేర్గా వస్తాయి అన్నమాట. ఓకే, యూ విల్ ఫైండ్ వెరీ రేర్లీ క్వశ్చన్స్. ఓకే, వెరీ రేర్లీ. Yes, 20 by 9. 20 by 9 is the correct answer. 20 by 9. Okay, right. Next. Now, one more question, Andy. This is one more model you can expect from, auto transformer. A 400 volt by 220 volt, 400 volt by 200 volt transformer has full load voltage regulation of X per unit at 0.8 power factor lagging. If this transformer is used as an auto transformer with voltage rating 400 volt by 600 volt or 200 volt by 600 volt, then what is the voltage regulation? Ikkada point entante, a 2 winding transformer is given and its voltage regulation is X per unit. Okay, 2 winding transformer voltage regulation in per unit is equal to X per unit. If it is converted into auto transformer, what is the voltage regulation? Remember, auto transformer voltage regulation is equal to 1 minus k times of 2 winding transformer voltage regulation. ఓకేనా? అయితే మనం ఆటో ట్రాన్స్ఫార్మర్ కూడా 2 మోడల్స్ యూజ్ చేశారు. వాట్ ఈస్ ద ఫస్ట్ మోడల్? 400 by 600. Okay, if it is 400 by 600 volt auto transformer, then what is the ratio K? K is always equal to LV by HV. That is 400 by 600. Is it not 2 by 3? Right. If K is 2 by 3, what is the voltage regulation of auto transformer? it is 1 minus K, 1 minus 2 by 3 times of voltage regulation of two winding transformer is X given. What is 1 minus 2 by 3? 1 by 3. Is it not simply X by 3? Okay. First transformer X by 3. అంటే ఈ రెండు పోయాయి ఆప్షన్స్ లో ఆల్రెడీ. X by 3, X by 3, X by 3. Now, what about the second design? In the second design, what they are using? 200 volt by 600 volt. 200 volt by 600 volt auto transformer design. So, what is the K value? LV by HV. That is 200 by 600. Is it not 1 by 3? If K is 1 by 3, what is the voltage regulation of auto transformer? 1 minus K times of voltage regulation of two winding transformer. So it is 1 minus 1 by 3, two winding transformer X and then what is answer? 2 by 3 times of X. Okay, 2 by 3 times of X. So option D is the correct answer. So simple rule, simple formula you have to remember. Voltage regulation of auto transformer is equal to 1 minus K times of voltage regulation of two winding transformer. Right? Just a moment, Andy. I'll just bring my water bottle. Okay, right. So X by 3 and 2X by 3 are the answers. Okay, so that's the end of questions from transformers. Inka there are many questions and almost 150 questions were there from transformers alone in PS Bimbra textbook. I selected some important questions. Okay, the drawback is, as I said, PS Bimbra textbook do not have three-phase transformers questions. Okay, right. Now let's see in DC machines. Now questions are from DC machines now. Okay, in DC machines, the field flux axis and armature MMF axis are respectively. Okay, please transfer your brain from transformers to DC machines now. Okay, switch your brain. This is where you need to be extremely good during the examination hall. Okay, oh, just a moment. Right. Okay, in DC machines, the field flux axis and armature MMF axis are respectively along which axes? Okay, now, so see, field flux means it is a stator flux. Armature flux means it is a rotor flux indirectly, right? For example, if you select a two-pole machine like this, for example, this is north pole and here you have south pole. This is a stator part. This is the armature part. Okay. Now, what is meant by polar axis and what is meant by interpolar axis? You know, the axis which is passing through the poles, this is nothing but polar axis. Okay, polar axis. Polar axis is also known as direct axis of the machine. And the axis which is perpendicular to these poles, this is interpolar axis. Interpolar axis is also known as quadrature axis. Quadrature axis. Okay. Now, let us create some number of coils in this, rotor. Imagine there are many coils available like this. These are all the armature coils. Okay. Now, flux will always flow from which pole to which pole? North pole to south. This is how stator flux will flow, indirectly field flux. You can easily understand field flux is along which axis? Direct axis. Field flux is along direct axis, along direct axis, along direct axis. That means two options are already removed. Okay. Now this stator flux will induce EMF in armature. Imagine the machine was rotating in clockwise direction. Then under north pole, cross polarity EMF will be induced. Under south pole, dot polarity EMF will be induced. How to find out polarity of induced EMF? And Polarity of induced EMF you can identify using Fleming's right hand rule. అది మొత్తం నేను ఎక్స్ప్లెయిన్ చేయట్లేదు. నార్త్ పోల్ దగ్గర క్రాస్, సౌత్ పోల్ దగ్గర డాట్ వస్తుంది. Now once EMF is induced, can I say current will also flow? This is nothing but armature current. The current passing through rotor is nothing but armature current. Now the moment you know the direction of armature current, you can identify armature flux also. How to identify armature flux direction? Right hand thumb rule. See, all these conductors are carrying the current into the plane. These conductors are carrying the current out of the plane. So armature flux is vertically in the downward direction. Armature flux is vertically in the downward direction. This is armature field. That is armature field. So can I say armature field is along which axis? Quadrature axis of the machine. Quadrature axis ne manam emantamu interpolar axis అని కూడా పిలవచ్చు. Interpolar axis. Interpolar axis. Interpolar axis. Okay. Right. Interpolar axis. Okay. So the field flux is along direct axis and armature flux is along interpolar axis. Armature flux is along interpolar axis. Okay. Fine. Okay. Next. One more question from DC machines. Right. Go through this question and right. Consider the following statements regarding the magnetization characteristics of a DC generator. Magnetization characteristics means open circuit characteristics, also known as no load characteristics of the machine, right? So the moment you see the word magnetization characteristics, this is open circuit characteristics of the machine. You remember, open circuit characteristics are drawn between generated EMF of the machine with respect to field current and by rotating the rotor at a constant rated speed. By rotating the rotor at a constant rated speed. And it will start from residual EMF and it will increase up to knee point. Later it will be saturated. This is known as magnetization curve of a transformer. Ikkada point entante, you look at EG. What is the formula for EG in DC generator? Ka phi into omega. Here Ka is known as armature constant and we are drawing this graph at a rated speed, at a constant rated speed. Speed constant, Ka constant. Then Eg is directly proportional to flux. Flux is directly proportional to field current. Ante indirectly on the y-axis we have either generated EMF or field current. Edaina teesukovachu. So now what is the correct answer? And look at the first statement. It represents the variation of field flux with field current. Correct, right? Eg is directly proportional to flux only. So therefore, this no load characteristics is representing variation of EMF with respect to field current or variation of flux with respect to field current. Anything is correct. Okay. So first statement is correct. It represents the variation of, field flux with field current. Next, what is the second statement? Variation of open circuit terminal voltage. What is meant by open circuit terminal voltage? EG. Open circuit terminal voltage is nothing but EG with field current, IF, and is independent of speed. Independent of speed. That is the second statement. Okay. Why it is independent of speed? That is a wrong statement, right? It is dependent on speed and we are keeping the speed as a constant value. ఒకవేళ స్పీడ్ చేంజ్ అయిపోతే ఈఎంఎఫ్ కర్వ్ కూడా చేంజ్ అయిపోతుందండి. ఓకే, ఇఫ్ స్పీడ్ ఇంక్రీజెస్ ఈఎంఎఫ్ విల్ ఇంక్రీజ్, ఇఫ్ స్పీడ్ డిక్రీజెస్ ఈఎంఎఫ్ విల్ డిక్రీజ్. సో ఇట్ ఈస్ డిపెండెంట్ ఆన్ స్పీడ్, నాట్ ఇండిపెండెంట్ ఆఫ్ స్పీడ్. నెక్స్ట్, ఇట్ ఈస్ నాన్ లీనియర్ ఫ్రమ్ 0 to rated field current. It is initially linear అండి, later it will be non-linear. Okay, so from 0 to field current non-linear అంటే తప్పు. Initially it is linear, later once saturation reaches it will be non-linear. It helps to determine critical field resistance. Yes, correct. Critical field resistance ఎలా find out చేస్తాం? Yes, we can find out critical field resistance by drawing a tangent. ఈ ఈఎంఎఫ్ కర్వ్ కి మనం టాంజెంట్ డ్రా చేసాం అనుకోండి, ద స్లోప్ ఆఫ్ దిస్ టాంజెంట్ ఈజ్ నథింగ్ బట్ క్రిటికల్ ఫీల్డ్ రెసిస్టెన్స్. ద స్లోప్ ఆఫ్ దట్ టాంజెంట్ ఈజ్ నథింగ్ బట్ క్రిటికల్ ఫీల్డ్ రెసిస్టెన్స్. ఓకే, it always starts from origin? Wrong. It will not start from origin, it will start from residual voltage. It will start from residual voltage. So what are the correct statements? 1 and 4 are the only correct statements. 1 and 4 are the only correct statements, right? 1 and 4 are the only correct statements. Sometimes question lo wrong statements kuda adugutaru. Wrong statements adigite 2, 3, 5 are the wrong statements. Okay, right. Clear? Critical resistance is important. Critical resistance is nothing but slope of the tangent drawn on the EMF curve. If you draw a tangent on the EMF curve, and the slope of that tangent is nothing but critical field resistance. Okay, right. Okay. Now, this is an important question. This is an important question. Go through it. నిద్ర వస్తుందా బాబు? 10 అవుతుంది. ఇట్ విల్ టేక్ అనదర్ 2 hours అట్లీస్ట్. పేషెన్స్తో వినండి. మీకు ఇంట్రెస్ట్, ఒకవేళ నిద్ర వస్తే పడుకోండి, నో ప్రాబ్లం. యూ కెన్ వాచ్ లేటర్. రికార్డెడ్ మోడ్ ఉంటుంది కదా. ఓకే, ఎనీవే, సో గో త్రూ నెక్స్ట్ క్వశ్చన్. A DC shunt generator builds up to a voltage of 220 volt at no load while running at its rated speed. If the speed of the generator is raised by 25%, keeping the circuit conditions unaltered, then what will happen to the voltage for which the machine would build up? Yes, what will be the new voltage? See guys, initially the voltage was 220. Okay, it's a shunt generator rotating at rated speed. Now the speed of the machine is raised by 25%. Okay, initially the speed is raised by 25%. Remember, it's a shunt generator. If it is a shunt generator, you can draw the circuit. This is the armature part of the generator, generated EMF, armature current, and armature resistance. Field winding is connected in shunt with armature. This is the field winding. So this is a field resistance, this is a field current. Okay, now what they said, what is the formula for EG? We all know that EG is equal to Ka phi into omega. So initially speed rises by 25%. If omega increases by 25%, immediately EG will also rise by 25%. ఎందుకంటే directly proportional కదండి. If speed rises by 25%, EG also rises by 25%. But story is not completed. The moment when EG increases, is it a closed loop, right? Whenever voltage increases in a loop, what will happen? The current passing through that loop will also increase. Because of this 25% rise in voltage, the field current will also rise. Okay, see, current passing through this loop will depend upon this voltage only. So whenever voltage increases, the current will also increase. Now, if a field current increases, automatically the flux will also increase. Remember, this field current will also increase by 25%. If a field current increases, flux will also increase, but it may not increase by 25%. Some small value it will increase. Exact 25% ఎందుకు increase కాదండి? Saturation ఉంటుంది కాబట్టి. Flux may not increase like field current. Definitely some finite value it will increase. Now, when flux increases, EG will also increase. Ante the final point is, EG is increased by just 25% or more than 25%? More than 25%. Therefore, EG increases by more than 25%. More than 25% ante meaning entandi? The new EG is more than 1.25 times of the old EG. What is the old EG? 220. It is more than 1.25. Okay, and it increases to a value greater than 1.25 times. Okay, na? చాలా మంది ఆప్షన్ బి ఆన్సర్ కరెక్ట్ అని చెప్పారు, బట్ దట్ ఈస్ రాంగ్ అండి. It will initially increase by 25%, but that 25% rise in voltage will increase the field current also, because it's a loop, right? It's a loop. When field current increases, again flux will increase. If flux increases, again voltage will increase. Can you tell me when second option will be the correct answer? When option B, second option will be correct answer? Yes, if it is a separately excited machine. For example, if the same question is given as separately excited generator, we know in separate excitation, flux is a constant value. If flux is a constant value, if voltage increases by 25%, if speed increases by 25%, voltage will also increase by 25% only. అప్పుడు మీకు సెకండ్ ఆప్షన్ కరెక్ట్ అవుతుందండి. ఓకేనా? ఎస్, గాట్ ఇట్. బట్ ఇట్ ఈస్ అ షంట్ జనరేటర్. So when voltage increases by 25%, when speed increases by 25%, voltage will increase by more than 25%. More than 25%. Yes, correct. Separately excited. Okay. Right. Now, this is another important question, Andy. This is another important question. Go through it. This is also important. Try to answer this. A DC shunt generator having a shunt field of 50 ohm was generating normally at 1000 rpm. The critical resistance of this machine was 80 ohm. Due to some reason, the speed of the prime mover became such that the generator just failed to generate any EMF. What is the speed at the time must be, okay? Yes, at what speed machine failed to build up the voltage? Okay, right. So point ఏంటంటే, the machine is having a field resistance of 50 ohm. It's the field resistance, and it was generating normally. Normally means it will generate rated voltage at 1000 rpm. Now, critical resistance of this machine was 80 ohm. Due to some reason, speed changes. At what speed machine failed to generate EMF? Generally, if speed reduces, machine will fail, or if speed increases, machine will fail. Yes, machine will generally fail if speed reduces. If speed reduces, machine will fail. At what speed? At below which speed machine will fail? And yes, below critical speed machine will fail. దీన్ని మనం రెండు విధాలుగా ఆన్సర్ చేయొచ్చు. వన్ ఈజ్ ఎ సింపుల్ షార్ట్ కట్, అనదర్ వన్ ఈజ్ ఏ కన్వెన్షనల్ ప్రొసీజర్. యు సీ దట్ if you take generated EMF on y-axis and field current on x-axis, initially machine was rotating at 1000 rpm, field resistance was a 50 ohm, and machine was generating normally. Imagine this is the EMF curve. Voltage ఇక్కడ వరకు జనరేట్ అవుతుందండి. This is the rated voltage. This is the rated voltage. And that rated voltage came at how much field resistance? Yes, that rated voltage came at a field resistance of 50 ohm. Just a moment. Okay. So this voltage was generated at a field resistance of 50 ohm. This is a 50 ohm curve, and this is a 1000 rpm curve. Okay. Now, what is the critical resistance? I just told you, critical resistance means it is like a tangent to the EMF curve. You just draw a tangent to this EMF curve. This is 80 ohm. This 80 ohm is more than 50, right? Now, at some speed, machine will fail to build up the voltage. As I mentioned, machine will fail to build up the voltage if speed reduces or if speed increases. If speed reduces, for example, 1000 rpm reduces to 900, 800, 700, then EMF will also keep on reducing, right? At one particular speed, the EMF curve will be like a tangent to this resistance. This is what we call it as critical speed. I have to answer this speed now. So what is the relation between critical resistance and critical speed? Yes, critical speed is directly proportional to critical resistance. Critical speed is directly proportional to critical resistance. ఇప్పుడు మీరు క్లియర్గా అబ్జర్వ్ చేస్తే 1000 RPM స్పీడ్ ఉన్నప్పుడు వాట్ ఈస్ ద క్రిటికల్ రెసిస్టెన్స్ 80 ఓమ్. అలానే ఈ ఒమేగా సి అనే క్రిటికల్ స్పీడ్ ఉన్నప్పుడు వాట్ ఈస్ ద క్రిటికల్ రెసిస్టెన్స్ 50 ఓమ్. సో దేర్ ఫోర్ ఐ కెన్ రైట్ ఒమేగా 1 బై ఒమేగా 2 ఈజ్ ఈక్వల్ టు R1 బై R2. 1000 RPM ఉన్నప్పుడు what is the critical resistance అండి? See, for 1000 RPM curve, the tangent is 80 ohm. 80 ohm is the critical resistance. అదే నెక్స్ట్ 50 ohm critical resistance అయితే what is the speed? You have to find out this speed. This is the answer. It will be 50 by 80 times of 1000. 50 by 80 times of 1000. 50 by 80 times of 1000. So how much ఎంత వస్తుందండి కరెక్ట్? Yes, 625 RPM, right? 625 by 800, 625. Yes. So if the speed is below 625 RPM, the machine will fail to build up the voltage. దీన్ని ఇప్పుడు మనం సింపుల్ గా ఎలా ఆన్సర్ చేయాలి? In a simple manner, one rule is very important. Critical speed and critical resistance are directly proportional. ఒకటే గుర్తుపెట్టుకోండి, డైరెక్ట్లీ ప్రపోర్షనల్ కాబట్టి హై స్పీడ్ డివైడెడ్ బై లో స్పీడ్ ఈజ్ ఈక్వల్ టు హై రెసిస్టెన్స్ డివైడెడ్ బై లో రెసిస్టెన్స్. మనకేంటి ఇప్పుడు ఒక స్పీడ్ ఆల్రెడీ ఇచ్చారు, 1000 RPM ఈజ్ ఆల్రెడీ గివెన్ అండ్ మెషిన్ విల్ ఫెయిల్ టు బిల్డ్ అప్ ద వోల్టేజ్ ఇఫ్ స్పీడ్ రెడ్యూసెస్ ఆర్ స్పీడ్ ఇంక్రీజెస్ అండి. ఇఫ్ స్పీడ్ రెడ్యూసెస్, దట్ మీన్స్ ఆన్సర్ ఈజ్ డెఫినెట్లీ లెస్ దాన్ 1000. Less than 1000 means it will be low speed, right? So therefore, high speed was given, low speed is the answer we need. And మనకి ఇచ్చిన వాటిలో రెండే రెసిస్టెన్సెస్ ఉన్నాయి, ఒకటి 50 ఓమ్, ఒకటి 80 ఓమ్. 80 is high value, 50 is low value. 80 ohm is high, 50 ohm is low. This is how you can find out that low speed. Okay, now? So one should understand machine will fail to build up the voltage only when speed reduces. Machine will fail to build up the voltage only when speed reduces. Speed reduces అయినప్పుడు అంటే మన ఆన్సర్ వచ్చేసి లో స్పీడ్ అన్నమాట. The answer must be low speed. So it was 625 RPM. So critical resistance and critical speed both are directly proportional to each other. Okay, na? Yes, that is the answer. 625 RPM. Okay. Next, one more important question. Yes, C is the correct answer. Correct. Right. Go through this question, guys. Right. Go through this question. A belt-driven cumulatively compound DC generator is delivering power to DC mains. If the belt snaps, what will happen to this particular machine will be? Right. It's a cumulative compound DC generator. First of all, what is meant by compound generator? Compound generator is a machine which is having both shunt field as well as series field. Okay. So that means it will have two field windings. Imagine this is the armature part of the machine. This is the generated EMF, armature resistance. So it will have a series winding as well as shunt winding. Okay. And you can select either long shunt connection or short shunt connection. Both will give you same answer. Here the terminal voltage was there. Now most importantly, it was a generator initially. DC generator. Delivering power to DC mains. DC mains ante entante it's a DC bus bar. DC bus bar. Bus bar means it's a constant voltage, right? And as the machine was a generator, current was generated by the machine. Current was generated by the machine. This is the load current. This is the shunt field current. Okay. Now, as it is a generator, Eg is more or Vt is more? Eg is greater than Vt. Eg is greater than Vt. And remember, Eg formula is Ka phi into omega. Now, what happens suddenly? The belt snaps. Belt snaps means indirectly what? Prime mover is disconnected. The one who is rotating the machine, that prime mover is disconnected. So, what will happen once prime mover is disconnected? Prime mover is disconnected. See, the moment when prime mover is disconnected, the machine started to decelerate. The machine will decelerate. Decelerate means what? Speed will decrease. Enduku machine decelerate avutundandi? Who is rotating the machine so far? So far, the machine is driven by external prime mover. That prime mover is disconnected. So the one who is rotating the machine is not available now. So the moment the prime mover is disconnected, machine will decelerate. The speed will decrease. If speed decreases, what will happen to generated EMF also decreases. Okay. So generated EMF keep on decreases and finally generated EMF becomes less than terminal voltage. Generated EMF becomes less than terminal voltage. Why? Because terminal voltage doesn't change, right? Only Eg is reducing. Finally, Eg becomes less than Vt. So now the moment Eg becomes less than Vt, current direction will reverse. Current will always flow from higher potential to lower potential. So therefore, current will now drawn by the machine rather than generating. Machine will absorb the current now. Okay. Let me remove this. Yes. Now the machine was absorbing the current. It was absorbing the current. Whatever the current is absorbing, a part of the current will go to armature, remaining part of the current will go to shunt field. So the machine is now acting like a motor. Because it was absorbing, the machine will act like a motor. But the point is, if you compare generating mode, current is passing in this direction through field winding, series field, but now current is reversed. In series field, the current is reversed. Shunt field, the current was not reversed. Only series field current is reversed. Initially, this is which connection? Cumulative compound. What is meant by cumulative compound? Total flux is equal to shunt flux plus series flux. But the moment it becomes reversed currents, now the total flux is equal to shunt flux minus series flux. Why only series is reversed? Armature current is reversed, so series flux is reversed. Therefore, the machine will now act like a differential compound motor. The machine will act like a differential compound motor. Yes. It is acting like a differential compound motor. అయితే ఇక్కడ మోస్ట్ ఇంపార్టెంట్ థింగ్ ఏంటంటే, విల్ ద మెషిన్ రొటేట్ ఇన్ ద సేమ్ డైరెక్షన్ ఆర్ ఆపోజిట్ డైరెక్షన్? Who will decide the direction of rotation? And see, initially it is a generator, right? Remember, when the machine is acting like a generator, when the machine was acting like a generator, which torque will support the rotation and which torque will oppose the rotation? This rotor anukondi. Imagine the machine was rotating in clockwise direction. Prime mover torque will support the rotation, electromagnetic torque will oppose the rotation. This is the situation in generator. Okay. Now, prime mover torque is suddenly disconnected. Okay. Who is the only available? Electromagnetic torque. What is the formula for electromagnetic torque? Ka phi into Ia. Earlier, armature current was generated by the machine, but now armature current was absorbed by the machine. Therefore, can I say armature current reverses? Armature current reverses. What about flux and flux is same polarity? Why? Earlier total flux is shunt plus series. Total flux is positive. Okay. Now shunt minus series. Again, this is a positive flux only. Why? Why flux polarity does not change? Why? Because always shunt flux is dominating. In a compound machine, most important thing, always the dominating flux is shunt flux. And shunt flux polarity is not reversed. That means resultant flux polarity also not reversed. So resultant flux is still positive. అంటే మీనింగ్ ఏంటి? ఓన్లీ ఆర్మేచర్ కరెంట్ ఈస్ రివర్స్, ఫ్లక్స్ ఈజ్ సేమ్ polarity. That means it will be Ka into still positive flux, but armature current reverses because it is negative current. That means electromagnetic torque also reverses. Electromagnetic torque is also reversed. That means what? Anti-clockwise direction electromagnetic torque will now become clockwise direction electromagnetic torque. If electromagnetic torque is in clockwise direction, the machine will rotate in clockwise direction. This is motor now. Okay, Nandi? In motor, who will rotate the machine? Electromagnetic torque will rotate the machine. Electromagnetic torque will rotate the machine. Electromagnetic torque is now in which direction? Earlier it is anti-clockwise, but now it is clockwise. So now compare the direction of rotation. In generator, machine was rotating in clockwise direction. In motor also, machine was rotating in clockwise direction only. So finally, the machine will continue to rotate in the same direction. It will be a differential compound motor, but continue to rotate in the same direction. Okay na? ఇది ఒక డిఫికల్ట్ ప్రాబ్లం అండి. ఇంత షార్ట్ పీరియడ్లో మీరు ఇంత ముందు చదివి ఉంటే మీకు ఈజీ అనిపిస్తుంది, అదర్వైజ్ కొద్దిగా డిఫికల్ట్ అనిపించవచ్చు. ఓకే, ఆల్వేస్ సిరీస్ ఫీల్డ్ ఈజ్ లెస్ దాన్ షంట్ ఫీల్డ్ అండి. షంట్ ఫీల్డ్ ఈజ్ ఆల్వేస్ డామినేటింగ్. Shunt field is always dominating. Okay. So the machine will act like a differential compound motor and will continue to rotate in the same direction. Same direction. All right. Yes. Okay. Next. One more. It's a logical question. Simple question, but logically you have to answer. Look at this question. Right. The direction of generated EMF in the armature coil of a DC machine is. Direction of generated EMF in the armature coil of a DC machine. DC machine అన్నారు, జనరేటర్ మోటార్ అని చెప్పలేదు, రెండు స్టేట్మెంట్స్ ఇచ్చారు. అంటే సింపుల్ క్వశ్చన్, ఇన్ జనరేటర్ ఈఎంఎఫ్ అండ్ కరెంట్ విల్ బి ఇన్ ద సేమ్ డైరెక్షన్ ఆర్ ఆపోజిట్ డైరెక్షన్. మోటార్ ఈఎంఎఫ్ అండ్ కరెంట్ ఇన్ ద సేమ్ డైరెక్షన్ ఆర్ ఆపోజిట్ డైరెక్షన్. రిమెంబర్, generator. So EMF will generate the current. So EG and IA same direction. Okay. Motor lo EMF name antam manam. We call it as a back EMF. Back EMF means it is opposing the current. It is opposing the current. So EMF and current both are in opposite direction. Generator means the voltage will generate the current. So voltage and current are in the same direction. Motor, it will absorb the current. And inside the motor, there will be back EMF. That back EMF will oppose the current flow, right? Okay. So, simple question. So, generator, current will be same as that of a voltage. Motor, current will be opposite to that of voltage. So, 1 and 4 are the correct statements. 1 and 4 are the correct statements. Okay. 1 and 4 are the correct statements. Yes. Fine. 1 and 4 are the correct statements. Next. Okay, this is a repeated question in many exams. Once again, simple problem, go through it. A 220 volt DC machine has an armature resistance of 1 ohm. If the full load current is 20 ampere, what is the difference in the induced voltages when the machine is running as a motor and as a generator is? Okay. Yes, it's a 220 volt DC machine and has an armature resistance of 1 ohm. If the full load current is 20 ampere, what is the difference between Generated voltage to motor voltage. See, if it is a generator, what is the formula for generated EMF? Generated EMF is equal to Vt plus Ia Ra, right? What is the terminal voltage? 220. Armature current 20 ampere. What is armature resistance? 1 volt. So it will be 220 volt. If it is act like a motor, then the EMF is known as back EMF. What is the formula for back EMF? Vt minus Ia into Ra. Vt was 220, armature current 20, armature resistance 1 ohm. So back EMF was 200 volt. Now generated voltage was 220, back EMF was 20. Terminal voltage 220 kadandi. I made a mistake. Terminal voltage was 220, correct? 220. Okay, this is 220. If this is 220, this will be 240. This is 240 volt. Okay. So what is the difference between both voltages now? Generated EMF to motor EMF. The difference between both EMFs is equal to 40 volt. 40 volt. Okay, simple problem. Right. 40 volt is the difference between generated EMF to motor EMF. 40 volt. Okay, read this problem. Okay. A bipolar DC machine with interpoles has a main pole flux of phi per pole and interpole flux of phi I per pole. The yoke of the machine is divided into 4 quadrants by the main pole axis and the commutation axis. What is the flux distribution in the 4 quadrants is the question. Okay. Yes. What is the flux distribution in the 4 quadrants? This is a difficult question. You should understand the theory part of the problem clearly first. A bipolar DC machine with interpoles has a main pole flux of phi per pole and a interpole flux of phi I per pole. The yoke of the machine is divided into 4 quadrants by the main pole flux and the commutation axis. So what is the correct answer? Meek ippudu commutating poles means what? Interpoles only. Okay, interpoles. Okay, so let's answer this problem. Fine. So very clearly, it was a bipolar DC machine. Okay, let's consider 2-pole machine. It will be easy. Imagine this is the yoke part of the given DC generator. This is the yoke part. And I am assuming 2 poles. Imagine these 2 are the main poles. Okay, here we have a north pole and a south pole. And these are the interpoles. Here we have interpoles. Right. So for example, if it is a generator, assume the machine was rotating in clockwise direction, then the polarity of interpole will be same as that of main pole ahead. This will be south, this will be north. Okay. Now flux will always flow from which pole to which pole? North pole to south pole. Therefore, the main pole flux will flow like this. This is main pole flux. What is the value? Phi. Once the flux reaches to this yoke, automatically it will divide into 2 parts, right? Phi by 2 here, phi by 2 here. This is how the main pole flux is flowing. I am using black color to represent main pole flux. Right? Okay. Now interpole flux. Interpole flux was phi I. Let us use a different color. This will also flow from north pole to south pole only, right? This is the interpole flux. Phi I. Okay. So now once it reaches, flux is always a closed path, right? Once it reaches yoke, half of interpole flux will go this way, phi I by 2, remaining half will go this way, phi I by 2. Flux is a closed path. This is how interpole flux was traveling. Arrow marks are important. That's all. Now, in every part of the yoke, you have to find out the flux. Okay. మరొకసారి arrow marks clear గా observe చేయండి. Black color is the main flux. You look at this arrow mark, upward direction. This is how the main flux was going. Main flux was going. Main flux was going. This is a downward direction. 5 by 2 main flux. Okay. Now coming to interpole flux, the red line. The red line is the interpole flux. Interpole flux. This is interpole flux. Okay. So here, this is interpole flux. Okay. Now you divide the entire yoke into 4 parts, guys. Okay. You divide the entire yoke into 4 parts. That is along main pole axis and the interpolar axis. Okay. Look at this half, guys. In this half, is it not main flux and the interpole flux both are in the same direction? Arrow marks కనిపిస్తున్నాయి కదండి. Therefore, what is the resultant flux in this section? The total flux is equal to main pole flux 5 by 2, interpole flux 5 by 2. 5 by 2, 5 I by 2. అదే ఈ సెక్షన్ తీసుకుంటే మీకు arrow marks చూడండి. Interpole flux and main pole flux both are in opposite direction. Therefore, what is the total flux in this half? It is 5 by 2 minus 5 I by 2. Next, look at this half. Is it not main pole flux and interpole flux both are in the same direction? Therefore, the total flux is 5 by 2 plus 5 I by 2. Look at this half. I think this half should be, I made a mistake. Yes, this half is actually, look at the red line, arrow mark is in this direction. Okay. Entire circle పోయింది. Just a moment అండి. Okay, this is the yoke. Excuse me for this. Okay, so look at that. ఇక్కడ arrow mark నేను mistake చేశాను. Look at that. This arrow mark is coming downward direction. This must be downward direction. Okay, that means okay, this is the direction of interpole flux. Just arrow mark follow అవ్వండి అంతే. ఇలా ఫ్లక్స్ క్లోజ్ అవ్వాలంతే. ఓకే, అదే ఈ ఫ్లక్స్ ఇలా క్లోజ్ అవుతుంది. ఓకే, సో నౌ వాట్ ఈస్ ద రిజల్టెంట్ ఫ్లక్స్ ఇన్ దిస్ సెక్షన్? In this section, is it not main flux and interpole flux both are in opposite direction? So it is 5 by 2 minus 5 I by 2. అంటే మీరు క్లియర్ గా చూస్తే ఈ సెక్షన్ లో రెండు యాడ్ అవుతున్నాయి చూడండి, యాడింగ్. ఓకే, దట్ దీస్ ఆర్ ఆపోజిట్ సెక్షన్స్ ఆర్ అడ్జసెంట్ సెక్షన్స్ అండి. ఆపోజిట్ సెక్షన్స్ లోనేమో యాడ్ అవుతున్నాయి, అలాగే ఈ ఆపోజిట్ సెక్షన్స్ లోనేమో సబ్ట్రాక్ట్ అవుతున్నాయి. ఓకే, లుక్ ఎట్ ద కరెక్ట్ ఆన్సర్ నౌ. What is the correct answer? See, 5 by 2 plus 5 I by 2, two diametrically opposite sections. See, this section and this section diametrically opposite. మీరు 1 by 2 కామన్ ఏంటంటే 1 by 2 కామన్ తీస్తే 5 plus 5i. అదే ఇక్కడ 1 by 2 కామన్ తీస్తే 5 minus 5i. ఓకే, సో టూ ఆపోజిట్ సెక్షన్స్ లోనేమో సబ్ట్రాక్ట్ అవుతున్నాయి, రిమైనింగ్ టూ ఆపోజిట్ సెక్షన్స్ లోనేమో యాడ్ అవుతున్నాయి. సో వాట్ ఈస్ ద కరెక్ట్ ఆన్సర్ నౌ? 5 plus 5i by 2 in two diametrically opposite quadrants, 5 minus 5i by 2 in the remaining two opposite quadrants. So third option will be the correct answer. Right? Last option wrong అండి, ఎందుకంటే అడ్జసెంట్ సెక్షన్స్ లో యాడ్ అవుతున్నాయా సబ్ట్రాక్ట్ అవుతున్నాయా? అడ్జసెంట్ సెక్షన్ అంటే పక్క పక్కన చూడాలి. పక్క పక్కన సెక్షన్ చూస్తేనేమో ఒక దాంట్లో యాడ్ అవుతుంది, ఒక దాంట్లో సబ్ట్రాక్ట్ అవుతుంది. ఆపోజిట్ సెక్షన్స్ లో చూస్తే మాత్రం రెండిట్లో యాడ్ అవుతుంది, రెండిట్లో సబ్ట్రాక్ట్ అవుతుంది. గాట్ ఇట్? ఇది కొంచెం డిఫికల్ట్ ప్రాబ్లం అండి, మీకు క్లియర్గా ప్రాబ్లం అర్థమైతే ఈజీగా అనిపిస్తుంది. ఓకే, రైట్. ఓకే, Okay. So remember, flux is a closed path and north pole to south pole in flux through yoke it will complete its path through yoke. So that is just we applied a simple basic concept. Okay. Fine. Next, let's answer one more question. Yes, read one more question. Which of the following factors will improve commutation in DC machine? See, in DC machine, to improve commutation, we have two techniques, right? Resistance commutation and voltage commutation. Okay. So what is resistance commutation? Using high contact resistance for the brushes. Okay. If you use high contact resistance for the brush, definitely commutation will be improved. Commutation will be improved. Okay. High contact resistance for the brushes is the correct answer. High inductance of the coil undergoing commutation is wrong. Why? Because if inductance is high, reactance voltage will increase. What is the formula for reactance voltage? L into 2I by Tc. So if inductance of the coil increases, reactance voltage will increase. If reactance voltage increases, the delay in the current reversal process will also increase. Okay, that will make commutation more worse. Okay, so second statement was wrong. Next, shifting the brushes in the direction of rotation for generator and opposite to the direction of rotation for motor. Yes, it is correct. In a generator, generally because of armature reaction, MNA will be shifted in the direction of rotation. So you shift the brushes also in the direction of rotation. In motor, MNA will be shifted opposite to the direction of rotation. So you shift the brushes also opposite to the direction of rotation. Okay, correct. Narrow width for commutation bars. See, if you use commutation bars to have a narrow width, indirectly brushes must also be designed with narrow width, right? So you look at this formula, commutation time. What is the formula for commutation time? It is brush width divided by velocity of the commutator. Velocity of commutator. Okay. Yes. So if you use narrow width for commutator segments, brush width will also become very less, right? If brush width is very less, commutation time will reduce. Look at the formula. If commutation time reduces, again the reactance voltage will increase. If reactance voltage increases, the delay in the commutation process will also increase. The moment when the delay increases, arcing will also increase. That is a poor commutation. Okay. So what are the correct answers? 1 and 3 only. 1 and 3 only. 1 and 3 only. That is option B. It is not related to leading pole tip and trailing pole tip. Okay. Someone asked me, the last problem is not related to leading. See, they are not asking flux in pole tips. They are asking flux in the yoke part of the machine. Yoke part of the machine. Okay. Right. Fine. Anyway, so the correct answer will be 1 and 3 only. 1 and 3. Okay. Now this is another simple factual based question. And so if you know the rules, you can easily answer this question. Yes. Okay. Consider the following statements about commutating poles which are fitted on most large DC shunt motors. Commutating poles which are fitted on the most large DC shunt motors. Question is about motor commutating poles. Commutating poles are nothing but what? Interpoles. Commutating poles are nothing but interpoles. Okay, look at the first statement. The commutating poles are placed in the geometrically neutral plane and their number is usually equal to number of main poles. That is correct. What is meant by geometrically neutral plane? Geometrically neutral plane is also known as interpolar axis. Yes, commutating poles are located along interpolar axis and their number is usually equal to number of main poles. That means if there are two main poles, we have to use two commutating poles. Four main poles, four commutating poles. So first statement was correct. Next, the winding on the commutating poles is connected in series with shunt field winding. This is wrong. Remember, interpole winding or commutating winding is connected in series with armature, not in series with field winding. It is connected in series with armature. Okay. Next, polarity of the commutating pole must be that of the next pole ahead. This is wrong because the question is about motor. In motor, polarity of interpole is the same as that of main pole, is the same as that of main pole preceding to it. Preceding means what? Before. Ahead means after. Okay, it is the same as that of main pole preceding to it. But in the question they said it is the same as that of main pole ahead of it. Ahead is correct if it is generator, preceding is correct if it is motor. That's why third statement was wrong. Next, commutating poles neutralizes reactance voltage produced in the coil undergoing commutation. Yes, correct. Remember guys, interpoles will perform two duties. One is to neutralize cross magnetizing effect of armature reaction. Cross magnetizing effect of armature reaction. This is one purpose of interpole. Second purpose is to neutralize reactance voltage. This is another purpose of interpoles. So fourth statement was correct. So what are the correct statements, Andy? 1 and 4 are the correct statements. So second option will be the correct answer. Okay. Okay. Second option is the correct answer. Okay. Next, one more question. Yes. In DC machines, reactance voltage is proportional to armature current. Reactance voltage is proportional to core length. Reactance voltage is due to self flux of the coil undergoing commutation. Reactance voltage, armature cross flux is neutralized by interpole flux. Interpole MMF is more than armature MMF in the interpole zone. Yes, 5 statements were given. What are the correct statements is the question. Okay. First thing, reactance voltage formula we must know. What is the formula for reactance voltage? Reactance voltage is equal to L into di by dt normally. Now, in a coil undergoing commutation, okay, current will change from plus I to minus I, right? Within how much time this will happen? Within commutation time. So therefore, the change in the current is plus I to minus I. Therefore, that is 2I. So it is the inductance of the coil into 2I divided by within how much time? Commutation time. And this small I is also written as IA by A. Where small I is current passing through each coil. Current passing through each coil or current passing through each parallel path, both are same. Therefore, finally you can write reactance voltage is directly proportional to armature current. Yes, first statement was definitely correct. One option ruled out. Okay. Next, reactance voltage is proportional to core length. reactance voltage is proportional to core length. How do you define that? Core length. అక్కడ L అంటే length కాదండి. L is inductance of the coil. Don't say L is length, sir. So reactance voltage proportional to core length, correct? అలా చెప్పొద్దు. L is inductance of the coil. Right? Okay. సో ఆ సెకండ్ స్టేట్మెంట్ ని ఎలా మనం ఫైండ్ అవుట్ చేయాలి? కమాన్. ఎస్, సెకండ్ స్టేట్మెంట్ వాస్ రాంగ్ అండి. ఎందుకంటే రియాక్టెన్స్ వోల్టేజ్ ఈజ్ నాట్ ప్రపోర్షనల్ టు కోర్ లెంత్. కోర్ లెంత్ ఇచ్చారా? ఎస్, ఇట్ ఈస్ నాట్ ప్రపోర్షనల్ టు కోర్ లెంత్, ఇట్ విల్ బి ప్రపోర్షనల్ టు ఎయిర్ గ్యాప్ లెంత్. See, you are finding reactance voltage is proportional to inductance of the coil, right? What is the formula for L there? L is equal to N square by R, where N is number of turns and this R is reluctance of the air gap. What is the formula for reluctance of the air gap? Length of the air gap. So therefore inductance is inversely proportional to reluctance. Reluctance is inversely proportional to air gap length. Therefore reactance voltage is inversely proportional to air gap length. It does not depend upon core length, it will depend upon air gap length. So second statement was wrong. Next, reactance voltage is due to self flux of the coil under commutation. Yes, it is correct. Reactance voltage is a statically induced EMF and it is due to the change in the armature current only, right? That is creating self flux linkages. That is how reactance voltage is induced. Third statement is correct. Next, armature cross flux is neutralized by interpolar flux. Just now I told you interpoles are having two advantages. One is to neutralize cross magnetizing effect of armature reaction. Okay, so armature cross magnetization is neutralized by interpole flux. That is a correct statement. Okay, correct statement. Next, interpole MMF is more than armature MMF of the armature MMF in the interpolar zone. This is also correct. See, MMF of the interpole winding, ఎవరైనా చదువుకుని ఉంటే మీకు ఓకే. ఓకే, interpole winding has two MMFs, Z by 2P into IA by A plus length of the air gap by mu into flux density along interpolar axis. Okay, this is one more formula for interpole MMF. This is what we call it as armature MMF. This is armature MMF. So interpole MMF is greater than armature MMF. Okay, na? This is cross magnetizing effect and this is to neutralize reactance voltage. I told you interpoles are having two purposes: to neutralize cross magnetizing effect. That's why you need this much MMF. This is to neutralize cross magnetizing MMF. And it is also used to neutralize reactance voltage. To neutralize reactance voltage, we need additional MMF. This is the additional MMF required to neutralize reactance voltage. So overall interpole MMF is more than armature MMF. Therefore the correct answers are 1, 3, 4, 5 and 1, 3, 4, 5. No option was matching. I think the options were wrong. In my gut feeling is 1, 3, 4, 5 is the correct answer. 4 is definitely correct answer because interpoles are used to neutralize cross magnetizing effect of armature reaction. Okay, so 4 is also the correct answer. Not only 1, 3, 5, 1, 3, 4, 5 is the correct answer. 1, 3, 4, 5 is the correct answer. 1, 3, 4, 5 is the correct answer. Yes. Okay. Right. Next. Next question. A 440 volt DC shunt motor has a no load speed of 2000 rpm. It is running at 1000 rpm at full load torque, reduced armature voltage and full field. If load torque is reduced to 50% of the rated value with armature voltage and field voltage held constant previous values, what the speed increases to 1050 rpm. The armature voltage drop at full load is how much? Armature voltage. This is a difficult problem, Andy. So if you are interested, you can solve it. Okay. It's a 440 volt shunt motor. No load current is 0. Speed was 2000. So initial condition is of no load condition. This is like case number 1. Case number 1, which is no load condition. What is the terminal voltage? Terminal voltage was 440 volt. Armature current was 0. Speed was 2000 rpm. So calculate what is the back EMF of the motor. What is the formula for back EMF? Back EMF is always equal to Vt minus IaRa, but armature current was 0. So back EMF was equal to 440 volt. Fine. This is no load condition. Okay. Now, next condition. It is running at 1000 rpm at full load torque. Next case is full load torque case. But voltage is not same. It's a reduced voltage, but flux is a full flux. Okay. So case 2. In case 2, voltage is reduced, guys. VT2, we don't know. All right. Also, full load torque is connected. That's why armature current will be a finite value. Okay. And the torque, this is second case, right? So suffix 2. And the torque is full load torque. Speed was 1000 rpm. 1000 rpm. Okay. No? So flux is constant, guys. Flux is constant. That was given in the problem because it was clearly mentioned full field. So what is the new back EMF now? You remember this formula, EB is equal to Ka phi into omega. Flux was constant. So back EMF is proportional to speed. First case back EMF by second case back EMF is equal to N1 by N2. First case back EMF entandi 440. Second case back EMF we don't know. N1 was 2000 rpm. N2 was 1000 rpm. So the new back EMF was 220 volt. This is the new back EMF. And you can also write KVL equation here. What is the new back EMF? The new back EMF is equal to VT2 minus IA2 into RA. You know this is 220, but you don't know what is the voltage. You also don't know what is the current. Resistance is also not given, right? Okay, fine. Now in the next case, what happened? The load torque is again reduced. The load torque is reduced to 50% of the rated value. The load torque is reduced to 50% of the, okay, 50% of the rated value. Somebody said core length increases, the active length of the conductor also increases, so reactance voltage increases. That is wrong, Andy. See, reactance voltage depends upon inductance of the coil. Inductance does not depend upon length of the conductor, it only depends upon number of turns. Inductance will depend upon number of turns. Okay. For example, I have a core with 10 centimeter length. Okay, na? And I am using one turn here. Okay. What if the core length is increased to 20 centimeter? Core length is increased to 20 centimeter. Will the inductance going to change? No. Inductance will be same because the number of turns doesn't change, right? Only point is that if you increase the length of the conductor, generated EMF will change, not the reactance voltage. Reactance voltage does not change. Reactance voltage will only depend upon number of turns, not depends upon length of the conductor. Please understand that. Okay. Yes. All right. It only depends upon length of the, number of turns, not on the length of the conductor. If length of the conductor increases, generated EMF will increase, not the reactance voltage. Reactance voltage does not change. Generated EMF may change because generated EMF depends upon length of the conductor. BLV sin theta. If length increases, generated EMF will increase. Okay. All right. Fine. Hope you got it. Anyway, we are discussing this question. Now, in the next case, back EMF 220, you don't know what is the new terminal voltage, and this is a equation we got. Now, what happened in the next case? Load torque is reduced to 50% of rated value. Load torque is reduced to 50% of the rated value. So, that is case 3 now. In case 3, voltage is held same value. VT3 and VT2 both are same. Torque is reduced to 50% of the rated value. Okay. And the speed rises to 1050 RPM. Okay. 1050 RPM. Got it? See, as the torque changes, current will also change, right? What is the torque formula? Ka phi into Ia. As flux was constant, torque is proportional to Ia. And the torque becomes half. Therefore, current also becomes half. Therefore, Ia3 becomes half of Ia1. Ia3 becomes half of Ia1. Okay. Now, what about speed? Back EMF is equal to Ka phi into omega, flux constant. Back EMF directly proportional to speed. So, EB2 by EB3 is equal to N2 by N3. మనకి సెకండ్ కేసులో బ్యాక్ ఈఎంఎఫ్ ఎంత వచ్చిందండి 220 రైట్ 220 by EB3 I don't know is equal to 1000 by 1050. Okay, from this you can find out EB3. What is that? 1050 by 1000 times of 220. Okay, now you find out what is this back EMF. Use calculator there. Use calculator. Right. 1050 by 1000 into 220. 1 second. Yes, I am getting 231. Meeku calculator allowed undandi. These type of questions you can also expect. But I can write back EMF is equal to VT3 minus IA3 into RA. So 231 is equal to VT3 and VT2 both are same kadandi. So I can write VT2. IA3 is equal to half of IA2, right? Okay. So from this, VT2 is equal to 231 plus 0.5 IA2 RA. Now this VT2 you can substitute here. Then what will happen? I'll change the color. This VT2 you can substitute here. Then 220 is equal to, what is VT2? 231 plus 0.5 IA2 RA minus IA2 RA. Okay. So then 220 is equal to 231 minus 0.5 IA2 RA. So from this you can find out IA2 RA. Is it the answer we need? What is answer we need? The answer we need is the armature voltage drop. Can I say armature voltage drop is nothing but IA into RA only? IA into RA at full load. Full load means the second case. Second case. IA to RA. So you will easily get IA to RA there. It will be 11 by 0.5, 22 volt. 22 volt. Okay. The armature resistance drop is equal to 22 volt. 22 volt. 22 volt. Okay. Right. ఓకే, సో ద ఆన్సర్ వాస్ 22 వోల్ట్. 22 వోల్ట్. ఇది కొంచెం డిఫికల్ట్ ప్రాబ్లమేనండి. ఇంత డెప్త్ ఆఫ్ క్వశ్చన్స్ మీకు ఐడియా ఉంటే ఓకే, అదర్వైజ్ యూ కెన్ లీవ్ దెమ్ ఓకే ఇన్ ద ఎగ్జామినేషన్ హాల్. నో నీడ్ టు వరీ. ఓకే, ఎస్. ఓకే, నెక్స్ట్ వన్ మోర్ క్వశ్చన్. A permanent magnet DC commutator motor has a no load speed of 6000 rpm when connected to 120 volt DC supply. The armature resistance was 2.5 ohm and other losses may be neglected. What is the speed of the motor with a supply voltage of 60 volt developing a torque of 0.5 Newton meter? Permanent magnet motor, what is the meaning of it? Permanent magnet motor means flux is a constant value. Okay, flux is a constant value. It has a no load speed of 6000 rpm when connected to 120 volt supply. So initially it was a no load condition. What is the no load condition given? Yes, supply voltage was 120 volt. No load speed was 6000 rpm. And armature current is 0, right? Why? Because no load condition means current is equal to 0. Therefore, you will get a back EMF here. Back EMF is equal to Vt minus IaRa. Armature current was 0. So back EMF is only equal to terminal voltage. And what is the formula for back EMF? Back EMF is equal to Ka phi into omega. So you can separate Ka phi value here. Back EMF 120 by omega means 2 pi n by 60. 2 pi into 6000 by 60. Okay, it will cancel 100 times here. So 120 by 2 pi into 100. So this is the Ka phi value. Okay, you got Ka phi is a constant because the flux is a constant in this problem. Okay, now you can use the same Ka phi in the next case. In the next case, what is the torque given? 0.5 Newton meter. 0.5 Newton meter. Let's move to the next case. Loaded condition. In the loaded condition, torque is equal to 0.5 Newton meter. What is the formula for torque? Ka phi into Ia is equal to 0.5. Ka phi ఎంత వచ్చిందండి? ఇక్కడ కరెక్ట్గా క్యాలిక్యులేట్ చేయండి. మీరు క్యాలిక్యులేటర్ యూస్ చేస్తే వచ్చేస్తుంది. నా మొబైల్ స్విచ్ ఆఫ్ అయింది. మీరు క్యాలిక్యులేటర్ యూస్ చేయండి. ఐ విల్ యూజ్ మై క్యాలిక్యులేటర్ ఫ్రమ్ ది computer. 120 by 200 pi, right? So scientific calculator. Okay, 120 by 200 into pi. Okay, I got Ka 5.1909. 0.1909. Use that here. So 0.1909 into Ia is equal to 0.5. So Ia is equal to 0.5 by 0.1909. We will get armature current there. Okay, right. So divided by 0.5. Yes, 2.61 ampere. Okay, 2.61 ampere. Armature current was 2.61 ampere. Now what is the answer? Once I got armature current, I can find out back EMF of the motor now. What is the back EMF of the motor? Vt minus Ia Ra. Vt was equal to 120. Armature current was 2.61. Armature resistance is given, right? 2.5 ohm. 2.5 ohm. You will get back EMF. Once you got back EMF, you can easily find out the speed. Okay. Yes, it is 2.61 into 2.5. Yes, 113.45. 113.45. Now we know back EMF is directly proportional to speed because the flux was constant. Back EMF in the first case by back EMF in the second case is equal to speed in the first case by speed in the second case. First case lo back EMF entandi 120. Second case back EMF was 113.45. Speed in the first case was, how much is the speed in the first case? 6000 rpm, right? 6000 rpm by speed in the second case we have to find out. We'll get the answer. Okay, Yes, into 6000 by 120. I'm getting 5672 RPM. 5672 something I got. Any calculation mistakes, please correct them. Okay, 113.45 into 6000 divided by 120. Yes, 5672 RPM. Okay, I made a mistake and nobody told me. In the second case, voltage was not 120, right? Voltage was 60 only. I forgot to read that point. In the second case, voltage was not 120, guys. Voltage was 60 only. Voltage changes in the second case. Okay, you will not get 113 here. I made a mistake. You're all calculating along with me without understanding the mistake, right? So it was 60. 2.61 into 2.5. Okay. 2.5 minus 60. Yes, it is 53.45. 53.45 volt. Second case voltage was modified, right? So it was 53.45. 53.45. Now you will get the answer for new speed. Okay. Yes, 53.45. So 53.45 into 6000 by 120. Yes, so 2673 RPM. I got 2673 RPM. Okay, remember this formula was valid since flux is a constant value. It was a permanent magnet DC motor. Flux is a constant value. So we got 2673 RPM. So second option is the correct answer. Second option is the correct answer. Yes. Two 673 RPM. Yes, correct answer. Second option is the correct answer. The voltage was modified in the second case. Okay. Right. Okay. This is another important question, and go through this question. After this question, we will take a short break and then we will start synchronous and induction machines. Okay. This is the last question from DC machines. Okay. Read this problem. Right. A DC shunt motor is run under the following conditions. Important model, and it is a logical question. Please read thoroughly and answer it. Normal voltage with no additional resistance in armature or field circuits. 50% normal voltage with no additional resistance in armature or field circuits. Normal voltage with a small external resistance in the armature circuit of a value equal to the armature resistance. Normal voltage with some additional resistance in the field circuit. Normal speed of the motor would increase in the sequence. Normal speed of the motor would increase in the sequence. Okay, so the question is, you have to understand speed of the motor would increase in the sequence. That means low speed to high speed. Okay, that's what speed is increasing. So out of these four, which option will give you lowest speed? Which one will give you highest speed? That's the question. Which one will give you lowest speed and which one will give you highest speed? First of all, what is the formula for speed in a shunt motor? The speed formula in a DC shunt motor is Vt minus IaRa by Ka into phi. This is the formula for speed in a DC shunt motor. Okay. And this is how a shunt motor looks like. Field winding was connected in shunt with the armature. Okay. Now, what is the first statement, Andy? First statement, normal voltage with no additional resistance in armature or field. This is the first statement. Voltage is normal, no additional resistances. This is the speed in the first case. Second case em chesaru, 50% normal voltage with no additional resistance in armature or field. Voltage becomes a 50%. That means V becomes V by 2. See, it is a shunt motor, guys. In a shunt motor, whenever voltage becomes half, can I say field current will also become half? If a field current becomes half, flux will also become half. Flux will also become half. Okay? Minus no additional resistance in armature, right? 50% normal voltage with no additional resistance in armature or field circuit. Third case, normal voltage with a small external resistance in the armature circuit of a value equal to armature resistance. And the third case, voltage is normal, Vt, but extra resistance is added in armature circuit having a value which is equal to armature resistance. So this is Ia into not only Ra, we added extra resistance equal to armature resistance. So that means indirectly it will become Vt minus 2Ia Ra by Ka into 5. This is the third case speed. What is the fourth case? Normal voltage with some additional resistance in the field circuit. See, whenever you add additional resistance in the field circuit, field current will decrease. Whenever field current decreases, flux will also decrease. So therefore, fourth case, normal voltage with some additional resistance in our field circuit. Therefore, flux will decrease. Therefore, flux decreases. Can I say as the flux is decreasing, speed will increase? Therefore, omega 4 would be the highest speed. Would be the highest speed. Because flux decreases, right? Because flux decreases, speed will increase. Okay, omega 4 would have been the highest speed. Omega 4. That is the fourth one is the highest speed. Fourth one is the highest speed. Which one is the lowest speed, Andy? Which one is the lowest speed? Okay. Which one is the lowest speed? Think about it. Which one is the lowest speed? We have 4 equations. Yes, which one is the lowest speed? Come on. Which one is going to be the lowest speed? Second one or first one? You have only 2 options, right? According to A and D, lowest speed 1 or 2. 1 or 2. Who is the lowest speed? 1 or 2? Who is the lowest speed? 1 or 2? 1 is the lowest speed or 2 is the lowest speed? Come on. Yes, so 2 is the lowest speed. 2 is the lowest speed. 2 is the lowest speed. Second equation is the lowest speed. Why? Because voltage becomes half, flux becomes half. Then this resistance drop will increase, guys. Why? Because when you reduce voltage to half, current drawn by the motor will automatically increase, right? Current drawn by the motor will automatically increase. Why? Because imagine the machine was driving a constant torque load. Torque formula Ka phi into Ia. If torque is constant, Ia is inversely proportional to flux. Ia is inversely proportional to flux. Now what happens to flux here? Divided by 2. As a flux is divided by 2, armature current will be doubled. Armature current will be doubled. If armature current is doubled, IaRa drop is also doubled. IaRa drop is doubled. So voltage decreases, IaRa drop is doubled. So omega 2 is the lowest speed. So finally, 2 is the lowest speed, 4 is the highest speed. You can pick, this is going to be the correct answer. And then 3 and then 1. Why 3 is lowest speed again? IaRa drop increases, omega 3 is low speed, omega 1 is high speed. Correct? Okay. 2, 3, 1, 4. See, these are logical questions. Logically, you have to think and answer. Right? Okay. Okay, guys. So let's take a short break. So it's been more than almost 11 అవుతుందండి. 3 hours అయింది మనం స్టార్ట్ చేసి. సో లెట్స్ టేక్ 15 minutes బ్రేక్. Okay, then we will continue our discussion. 15 minutes break. It was 10:56 right now. We will start at 11:10 p.m. again. Okay. If you are sleepy, you are always welcome to sleep. Okay. నిద్రపోండి, ఎందుకంటే మీ డైలీ రొటీన్ నేను డిస్టర్బ్ చేయాలనుకోవట్లేదు. మీరు కావాలంటే రికార్డెడ్ సెషన్ రేపైనా వినొచ్చు, మీరు లైవ్లోనే చూడాలని నేను. ఇఫ్ యు ఆర్ ఇంట్రెస్టెడ్, దెన్ స్టే అవేక్ అండ్ వీ విల్ కంటిన్యూ synchronous machine and induction machine also. Okay, right. Okay. All right. Welcome back. So let's continue our discussion. We will be moving to the next subject, which is synchronous machines. Okay. Yeah. Okay. Just a moment. Hope everything is clear, right? Audio, video, everything. Okay. Right. So let's move to our next discussion. Right. A synchronous machine has its field winding on the rotor and armature winding on the stator. When running under steady state conditions, its air gap field is. First of all, it's a synchronous machine, okay? And we know in a synchronous machine, field winding will be on the rotor, armature winding will be on stator. In a DC machine, field winding will be on stator, armature winding will be on rotor, okay? Right. Now, what is that we know in case of a synchronous machine? For example, imagine this is the stator part, okay? All right. So assume that this is the stator part of the machine. Okay. Stator will have a three-phase balanced distributed winding. That's why stator field is always rotating. Stator field is always rotating. At what speed it will rotate? Synchronous speed. Okay. Next, coming to the rotor, you take either salient pole rotor or slip ring rotor. Rotor will be excited with DC supply. Okay. And rotor is stationary or rotor is rotating? Rotor is rotating. We will use a DC supply here. Rotor is rotating. Because of this, rotor field will also be rotating. Rotor field will also rotate. At what speed? Synchronous speed. And if you add both of them, we will get a resultant field that is known as air gap field. And this air gap field will also rotate at synchronous speed. So therefore, stator field is rotating at a synchronous speed, rotor field is rotating at a synchronous speed, air gap field is also rotating at a synchronous speed. Now what is the question? The question is about air gap field. The question is about air gap field. Air gap field is stationary with respect to stator. This is a wrong statement because stator is stationary, right? Stator means stator core, stator winding. Stator is stationary, but air gap field is rotating. So the relative speed is not zero. Therefore, first statement is wrong. Remember, girl, whenever I use the word called with respect to, that means I am talking about relative speed. Relative speed. Second statement, air gap field. The question is about air gap field. Air gap field is rotating at synchronous speed with respect to stator. That is correct. Because stator is stationary, stator speed is 0, air gap field is ns. What is the relative speed? Ns. That is correct answer. Next, air gap field is rotating at double ns with respect to rotor. That is wrong. Rotor is rotating at ns. Air gap field is also rotating at ns. What is the relative speed? 0, but they said double ns. That is a wrong statement. Next, air gap field is stationary with respect to rotor. It is correct. Why? Because rotor speed is ns, air gap field speed is ns. What is the relative speed? 0. 0 means stationary to each other. Okay. Next, air gap field is rotating at ns in the direction of rotor. Yes, it will rotate in the direction of rotor only. If rotor is rotating in anti-clockwise direction, the fields will also rotate in anti-clockwise direction. So therefore, the correct statements are 2, 4 and 5. This is the correct statement. That is the correct statement. Okay. If you apply the same concept to, DC machine, in a DC machine, stator field will be stationary, rotor field will also be stationary, air gap field will also be stationary. In a synchronous machine, all the fields are rotating in nature. Rotating in nature. Okay. Okay. Next, one more question related to construction of the machine. Okay. Go through this question. Consider the following statements. The synchronous generator used in thermal power stations. Okay. Thermal power stations means steam turbines, right? Thermal power station means steam turbines. Steam turbines are nothing but high speed turbines. Steam turbines are nothing but high speed turbines. High speed turbines. High speed turbines means we will use cylindrical rotor. Cylindrical rotor. If it is low speed, then we will go for salient pole rotor. So therefore, cylindrical rotor is a correct statement. And yes, we need slip rings. Why slip rings are required? Slip rings are required to give DC supply to rotor winding, right? Rotor winding is rotating. For a rotating winding, how do you connect external DC supply? Through slip rings. Okay. Yes, slip rings are required, are used to give DC supply to rotor. DC supply to rotor, because that DC voltage is outside the machine, winding is inside the machine. So rotating, yes or not, rotor winding is rotating. For a rotating winding, how do you connect stationary supply? Through slip rings. Okay, slip rings and brushes are required. Laminated rotor is a wrong statement. Why? Because rotor is excited with DC supply. Rotor is excited with DC supply. DC supply means iron losses are absent. Iron loss is 0. If iron loss is 0, no laminations. Generally, what is the purpose of lamination? The purpose of lamination is to reduce eddy current loss, and I said iron losses are 0, so no laminations are required. Next, stator slots in multiple of 6. That is correct statement. Stator slots in multiple of 6 is correct. Why you need slots in multiple of 6? For example, you take 3-phase winding. If nothing is given, we can consider 3-phase armature winding in stator. What is mean by 3-phase winding? A phase, B phase and C phase. Okay, we will always use balanced winding or unbalanced winding. Balanced winding. Okay, balanced winding means what? Every phase must have equal number of turns. For example, if A phase has one turn coil, let us say, one turn coil means how many conductors? 2 conductors. Then B phase will also use one turn coil. C phase will also use one turn coil. That means overall how many conductors are there? 6 conductors. That's why I need 6 slots in the machine. 6 slots. For example, what if I use 2 turn coil for phase A? 2 turn coil means what? We need 4 conductors. Then B phase will also require a 2 turn coil, right or not? Then you need 4 more conductors. C phase will also require a 2 turn coil. Okay, then 9, 10, 11, 12. Okay, overall 12 conductors. To place 12 conductors, you need 12 slots. What if phase A uses a 3 turn coil? 3 turn coil means what? 6 conductors, 6 conductors, 6 conductors. Overall 18 conductors are there. To place them, you need 18 slots. Next 24 slots, 30 slots, 36 slots. So number of slots are always integral multiple of 6. See, this is 6 into 1, 6 into 2, 6 into 3, 6 into 4. Slots are always integral multiple of 6. That is correct answer. Okay. Next, 3-phase star connected winding. Yes, armature winding is always star connected. What is the advantage of a star connected winding? Star connected armature winding. Yes, what is the advantage? See, star connected winding will have 2 advantages, I think. First one is, if the winding is star connected, line voltage will be root 3 times of phase voltage. Okay, that means higher line voltage is possible. For example, if the winding is delta connected, line voltage will be same as phase voltage. Therefore, to generate more line voltage, star connected winding is preferable. At the same time, if the winding is star connected, third harmonic voltage will be neutralized. Okay, for example, phase voltage has fundamental voltage as well as third harmonic voltage. V1 is fundamental harmonic voltage, V3 is third harmonic voltage. But when it comes to line voltages, only fundamental voltage will be present. Third harmonic voltage will be neutralized. Okay, so therefore, if I use a star connection, line voltage will be much higher value. Also, third harmonic voltage can be neutralized. That's why majority of alternators, armature winding is always a star connected winding. Therefore, the correct statements are 1, 2, 4, and 5. 1, 2, 4, and 5. Okay. Yes. Third statement was wrong. 1, 2, 4, and 5 are correct statements. Okay. Right. 1, 2, 4, and 5 are the correct statements. Okay. Okay. Next, we have a question from OC test and SC test in alternator. Okay, read that question. Open circuit and short circuit test on AC generator are conducted under which of the following conditions? Okay, so generally manaki OC test, SC test and OC test is used to draw open circuit characteristics. SC test is used to draw short circuit characteristics. Okay, what is the difference? During OC test, voltage will be rated value. Voltage will be rated value because we will use this test to generate rated voltage. And armature current will be zero, right? Armature current will be zero because machine is open circuited, no load condition. And we will use rated flux also. Flux is also rated value. Now, what about short circuit test? During the short circuit test, voltage is very small. Okay, because the load is short circuited, even a small voltage is also sufficient to circulate rated armature current. Armature current is rated value. And to generate small voltage, a small amount of flux is also sufficient. Okay, so therefore, OC tested nominal flux. Nominal means what? Rated flux. This is correct. OC tested nominal flux. SC tested nominal current. Nominal current means what? Rated current. Yes. Entire first statement was correct. Nominal means rated value. Okay, next. OC tested reduced flux. This is wrong. Why? Because during OC test, flux is rated value, not reduced value. Next. OC tested zero armature current. Correct? Armature current was zero because the terminals are open. And SC tested reduced flux. This is also correct. During SC test, flux is very small. Next, OC tested zero current. Yes, correct. OC test current is zero. SC tested nominal flux. Nominal flux or small flux? Small flux. This is wrong. Therefore, what are the perfectly correct statements here? 1 and 3 are the correct statements. 1 and 3 are the correct statements. Okay. So, what is the purpose of OC test? And OC test will be used to determine rated voltage in the motor. SC test is used to determine rated current. So if I have a OC test and SC test details, we can find out the synchronous reactance or synchronous impedance of the machine, correct? Yes. 1 and 3 are the correct statements. 1 and 3 are the correct statements. Okay, yes. Now, let's go through one more question. This is a factual based question, Andy. Question related to voltage regulation methods. We have different types of voltage regulation methods. We have EMF method, MMF method, Portier triangle method, also known as ZPF method, ASA method. Out of all of them, which one is the most accurate method? ASA method is the most accurate method. ASA method is the most accurate method. Okay, and imagine this most accurate method, and then who is the nearest accurate method? Yes, nearest accurate method means ZPF method, also known as Portier triangle method. Okay, and the lowest regulation will be measured by MMF method. MMF method will measure the lowest regulation, and EMF method will measure the highest regulation. This is the order you have to remember. Okay, MMF method will measure the lowest regulation, EMF method will measure the highest regulation, and this is the most accurate. Okay, and ZPF method is almost accurate. ZPF method is almost accurate. Okay, almost accurate. Now in the given question, they are only comparing EMF method, MMF method and ZPF method. I told you EMF method will measure the highest regulation. Therefore, this is 32% regulation. MMF method will measure the lowest regulation. That means 13%. In between the two, we have ZPF method. You can easily match that list. Okay, A is with 3, B is with 1, C is with 2. Okay, right. Clear? Okay. Another question. A typical question from synchronous machine. పెసిమిస్టిక్ ఆప్టిమిస్టిక్ అంటేనండి, ఆప్టిమిస్టిక్ అంటే ఏంటి, మన ఊహలకి దగ్గరగా ఉంటే ఆప్టిమిస్టిక్ అంటాం, మనల్ని సాటిస్ఫై చేస్తే ఆప్టిమిస్టిక్. రెగ్యులేషన్ ఎప్పుడు కూడా లో ఉండాలా, హై ఉండాలా? లో ఉండాలి. ఎవరు లోయెస్ట్ అని చెప్తున్నారు? ఎంఎంఎఫ్. అందుకనే ఎంఎంఎఫ్ ఆప్టిమిస్టిక్ అనమాట. మంచి రిజల్ట్ అని మనకి కావాల్సిన రిజల్ట్. రెగ్యులేషన్ ఎప్పుడు కూడా లో ఉండాలి. ఓకేనా? మీరు ఒక టెస్ట్ ఒక ఎగ్జామ్ రాస్తున్నారంటే ఆప్టిమిస్టిక్ రిజల్ట్ ఏంటి? మార్క్స్ ఎక్కువ రావడం. పెసిమిస్టిక్ రిజల్ట్ అంటే ఏంటి? మార్క్స్ తక్కువ రావడం. అలానే ఎంఎంఎఫ్ మెథడ్లో రెగ్యులేషన్ తక్కువ అంటే మనం అనుకున్న విధంగా వస్తుంది. రెగ్యులేషన్ తక్కువ ఉండాలి కదా, అందుకనే ఆప్టిమిస్టిక్ అనమాట. ఈఎంఎఫ్ అనేది పెసిమిస్టిక్. ఓకే, దూరంగా వెళ్ళిపోతే, మీరు అనుకున్న దానికి దూరంగా ఉంటే పెసిమిస్టిక్, అనుకున్న దానికి దగ్గరగా ఉంటే ఆప్టిమిస్టిక్ అనమాట. ఓకే, రైట్. మీరు ఇంజనీరింగ్ ఎగ్జామ్ రాస్తున్నారు, ఎవరు మిమ్మల్ని పెసిమిస్టిక్ ఆప్టిమిస్టిక్ అని అడగరు, వాల్యూస్ అడుగుతారు అంతే. ఓకే, డోంట్ వరీ. రైట్. నౌ లుక్ అట్ దిస్ క్వశ్చన్. Read the following statements about a cylindrical rotor alternator. 5 statements are given. You have to find out the correct statements. Yes. EMF generated by armature reaction MMF lags armature current by 90 degrees. Armature reaction due to intermediate lagging power factor is partially cross magnetizing and partially magnetizing. Air gap voltage leads the terminal voltage. Air gap voltage lags the field flux by 90 degrees. Armature reaction MMF lags the field flux by 90 degrees plus internal power factor angle. This is quite a difficult question, and these are the questions you can expect at AEE level exams. Okay, see, what is the first statement? EMF generated by armature reaction MMF lags armature current by 90. See, to answer such type of question, first fundamental point is very important. According to Faraday's law, EMF will always lag the flux by 90 degrees. EMF always lags the flux by 90 degrees. By 90 degrees. Ante meaning enti? If you take flux as reference, induced EMF will always lag that flux. Lag means clockwise direction by 90 degrees. But the point is, which flux, which EMF? For example, if this is a field flux, this will be field induced EMF. If it is armature flux, this will be armature induced EMF. If this is air gap flux, this will be air gap induced EMF. So that's important. Which flux, which EMF is more important. According to the first statement, they are talking about EMF generated by armature reaction MMF. Okay, now that means we are talking about armature induced EMF. Can I say armature induced EMF lags armature flux by 90 degrees? Correct. This is correct. Okay, now where is armature current? This is armature flux, right? Then armature current will be in phase with armature flux. Why? Because what is the formula for flux? Flux is equal to MMF by reluctance. MMF is equal to number of turns into current. Therefore, flux and current are directly proportional to each other. So armature flux is directly proportional to armature current. Okay, so if armature flux is in this phase, armature current will also be in the same phase. Is it not now? Armature induced EMF lags armature current by 90 degrees. Yes, that means first statement was correct. EMF generated by armature reaction MMF lags armature current by 90 degrees. That is a correct statement. Look at the second statement. Armature reaction due to intermediate lagging power factor is partly cross-magnetizing and partly magnetizing. This is wrong. Given question is a generator or motor? Generator. In generator, if the power factor is partially lagging, what is the nature of armature reaction? Partial demagnetization and partial cross-magnetization, right? In generator, finite lagging power factor. Finite lagging power factor. Yes, armature reaction will be partial cross-magnetization and partial demagnetization. Partial demagnetization. Okay, but they said magnetization, so second statement is wrong. Look at the third statement. Air gap voltage leads the terminal voltage. Air gap voltage leads the terminal voltage. To answer this, first you must understand equivalent circuit of alternator. If you clearly look at the equivalent circuit, this is the induced EMF of the alternator. This is armature reactance. After armature reaction, whatever voltage is available, this is the air gap voltage, also known as resultant voltage of the machine. Then we have leakage reactance and armature resistance. Finally, we have the load here, which is the terminal voltage. Across the load, whatever voltage is available, that is the terminal voltage. Now, what do we know in generator? In generator, terminal voltage will be always reference phasor, and induced EMF will lead the terminal voltage by an angle delta. Induced EMF will always lead the terminal voltage by an angle delta. Okay, so that means what? If you take terminal voltage as the reference, induced EMF will lead the terminal voltage by an angle delta. Then where is the air gap voltage? Can I say air gap voltage is in between the two? This node is a terminal voltage, guys. This node is induced EMF. Air gap voltage is in between the two. Okay. So air gap voltage will be in between the two. Okay. That means air gap voltage is lagging which voltage and leading which voltage? Yes, air gap is air gap voltage is lagging field induced EMF but leading the terminal voltage. So that's why third statement is correct. Air gap voltage leads the terminal voltage. This is air gap voltage and it is leading the terminal voltage. And it is lagging the field induced EMF. Got it? Okay. Next. Air gap voltage lags the field flux by 90. This is wrong. I just told you. If it is air gap voltage, this must be air gap flux. Air gap voltage lags air gap flux by 90, not field flux by 90. Which voltage will lag field flux by 90? Field EMF will lag field flux by 90. But air gap voltage lags air gap flux by 90 degrees. Okay. Next, fifth statement. Armature reaction MMF lags field flux by 90 degrees plus internal power factor angle. Is it correct or not? How do we decide it? Simple. You can do it by drawing a phasor diagram. Okay. Yes. If you draw a phasor diagram, you take field flux as reference. Then we know that field induced EMF will lag this flux by 90 degrees, right? Now, this induced EMF will generate a current known as armature current. Majority of loads in power system are lagging power factor loads, right? So let us consider lagging power factor load. Then armature current will lag this induced EMF by a power factor angle known as internal power factor angle. Correct? Now, if this is armature current, armature flux will also be in the same phase. Armature flux will also be in the same phase. Now tell me, what is the angle between main field flux and armature flux? Is it not 90 degrees plus internal power factor angle? Yes. So therefore, armature flux lags main field flux by 90 degrees plus internal power factor angle. That is a correct statement. Therefore, finally, the correct statements are 1, 3, and 5. 1, 3, and 5 is the correct statement. I know synchronous machines subject is quite difficult compared to other rotating electrical machines because we have to apply more basics, right? Okay. So 1, 3, 5 are the correct statements. Remember, induced EMF is always lagging the flux by 90 degrees. That induced EMF will generate the current known as armature current. Okay. Yes. So 1, 3, 5 are the correct statements. Okay. Next question. Next question. This is also important question. Read the problem. Okay, read this question. Consider the following statements regarding synchronous machine. Consider the following statement regarding synchronous machine. Okay. There are 5 statements given. The correct statements we have to find. See, in alternator, armature MMF leads field flux. Air gap flux lags field flux. Motor, who is leading, who is lagging. So the question is about simply which field will lead and which field lag in generator as well as motor. Okay, simple answers you have to remember. In a normal class, we use it to draw the phasor diagram. Lot of discussion will be there, but in this case, I would like to tell you simple, observation. Okay, that much discussion is not possible right now. It's actually 1 hour class. Okay, so we have to discuss quickly. Remember, guys, always you just apply common sense for any machine. After giving input, output will be generated, or after getting output, input will be given. What is the correct procedure? You first give the input, then output will follow it. Am I right? Output will always follow the input. Input is first, then output will be generated. That's why input leads and output lags. Lags means what? Follow it. It's a simple observation. For example, you consider a generator. Generator means what is the input? Mechanical power or electrical power? Mechanical power. Mechanical power is the input. What is the output power? Electrical power is the output. Now the point is, this mechanical power we will give to rotor part or stator part? Rotor part with the help of prime mover. That's why rotor part is going to lead. That is the input, leads. Output, electrical power, that will be generated from which winding? Armature winding. So therefore, stator, armature winding will lag. So therefore, in a generator, who will lead? Rotor field will lead. Stator field will lag. Stator field will lag. Remember, the fields will rotate in anti-clockwise direction at a synchronous speed. In between the two, we have air gap field that will also rotate at synchronous speed. This is generator. Now coming to motor. Motor means what is the input power? Electrical power is the input. Output is the mechanical power. This electrical power input will be given to stator or rotor. We will give it to stator. Mechanical output will come from rotor. That's why stator will lead, rotor will lag. So in case of motor, stator will lead, stator field will lead, rotor field will lag. Rotor field will lag. In between the two, we have air gap field. Air gap field. Everything is rotating at synchronous speed. And now look at the first question. In alternator, alternator means generator. Armature MMF leads the field flux. First of all, who is armature here? Rotor. Rotor is armature. Who is the main field? Stator. This is the main field. Okay, so in alternator, armature MMF leads field or lags field flux? Yes, it is lagging the field flux. So first statement was wrong. Second statement, in alternator, air gap flux. Look at that. This is air gap flux. Air gap flux lags the field flux. Yes, this is the field flux. Rotor is the field flux, right? Stator is the armature flux. Air gap flux lags the field flux. Yes, this is correct statement. Okay, that is correct statement. Now, next statement is about motor. Look at that motor. In motor, armature MMF leads field flux. First of all, who is armature? Stator is armature winding. Rotor is field winding. Field MMF or field flux, anything is same. So look at the third statement. In a synchronous motor, armature MMF leads the field flux. Yes, armature MMF leading the field flux. This is correct. Next, fourth statement. In synchronous motor, air gap MMF lacks the armature MMF. Yes, air gap MMF lacks the armature MMF. That is also correct. Fifth statement is again about generator. In a generator, field flux lacks armature current. See guys, this is armature field. That means, can I say armature current will also be in the same phasor? Yes. So field flux lacks armature current is wrong. It is actually leads armature current. So what are the correct statements? 2, 3, 4 are the correct statements. 2, 3, 4 are the correct statements. So these kind of questions you can answer only if you have preparation earlier. Okay, if you see directly, these questions looks very difficult. Okay, right. So 2, 3, 4 are the correct statements here. So simple rule. In case of generator, rotor field will lead, stator field will lag. In case of motor, stator field will lead, rotor field will lag. Okay. Input will always lead and output will follow it, lag. Okay na? Input ichin tarvate output vastundi. Please understand that. Okay. Next, one more question. Go through it. Consider the following statements for a three-phase alternator designed to operate at 0.85 power factor. For power factor greater than 0.85 lagging, armature heating is the limiting factor. Power factor greater than 0.85 lagging, rotor field is the heating is the limiting factor. Okay, so a power factor ki a heating limiting factor avutundi another question. See, actually machine is designed for 0.85 power factor. ఒకవేళ పవర్ ఫ్యాక్టర్ పెరిగింది అనుకోండి, పవర్ ఫ్యాక్టర్ అంటే ఏంటండి? cos5. cos5 is the power factor. This will indicate active power of the machine. sin5 will indicate the reactive power of the machine. What is the reactive power formula? Vi sin5. Active power Vi cos5. See, if power factor is greater than 0.5 అంటే మెషిన్ యొక్క రేటెడ్ పవర్ ఫ్యాక్టర్ కన్నా పెరిగింది. పవర్ ఫ్యాక్టర్ పెరిగిందంటే మీనింగ్ ఏంటండి? sin5 తగ్గినట్లే కదా. That means reactive power reduces. Reactive power reduces. If reactive power reduces, indirectly field excitation will also reduce. Field excitation will also reduce. That means if field excitation reduces, rotor does not overheat, right? Rotor does not overheat. So if power factor is greater than 0.85, rotor field heating is wrong. Why rotor does not heat? Because the field current decreases, right? Why? Reactive power decreases. But one point, if a power factor is greater than 0.85, is it not active power increases? Active power increases means armature current will also increase. Okay? Active power increases, armature current will be increased. Armature heating is the limiting factor. Yes. Armature heating is the limiting factor. Next, if power factor is less than 0.5, power factor reduces. That means cos5 reduces. If cos5 term reduces, is it not sin5 term increases? That means reactive power increases here. Reactive power ఎప్పుడు ఇంక్రీజ్ అవుతుందండి? ఫీల్డ్ ఎక్సైటేషన్ ఇంక్రీజ్ చేశాను కదా. ఎస్, ఇన్ ఆల్టర్నేటర్ who will control reactive power? Field excitation. Who will control active power? Steam input, right? So reactive power will increase only when field excitation increases. If field excitation increases, who will be overheated? Rotor field will be overheated. Yes, if power factor is less than 0.5, rotor field heating will be the limiting factor. Armature heating will not be the limiting factor. Armature heating is not the limiting factor. Why? Because reactive power increases means active power decreases. Active power decreases means armature will not overheat. Field is overheating. So therefore, what are the correct statements here? 1 and 4 are the correct statements. 1 and 4 are the correct statements. Okay. Right. So where you have to use the logic to answer this question, such type of questions. Okay. Right. Next, one more question. This is related to excitation conditions. I hope you remember field excitation conditions of synchronous generator and synchronous motor. Yes. A cylindrical rotor synchronous motor with negligible armature resistance operates at, first of all, it's a motoring machine. Okay, it's a motor. In a motor, what is overexcitation? Overexcitation means leading power factor. Okay, and EF cos delta is greater than VT. Correct? Next, under excitation. In motor, what is mean by under excitation? Under excitation means lagging power factor. EF cos delta is less than VT. Okay. What is mean by unity power factor? Unity power factor means normal excitation, right? Unity power factor means normal excitation. Normal excitation means what? Normal excitation. Normal excitation means unity power factor. This is the condition where EF cos delta is equal to VT. Okay. దీన్ని బేస్ చేసుకొని మీరు ఇప్పుడు ఆన్సర్ చేయాలి. ఓకే. సో ఫస్ట్ యూనిటీ పవర్ ఫ్యాక్టర్ EF cos delta equal to VT is correct. Lagging power factor, ఇప్పుడే చెప్పాం, lagging power factor means under excitation. EF cos delta greater than VT is wrong. Lagging power factor EF cos delta less than VT is correct. EF cos delta less than VT is correct. Next, what about zero power factor leading? See, remember, whenever power factor was zero, power factor 0 means cos phi is 0. Therefore, active power is 0. Active power 0 means delta is also 0. But they said zero power factor leading. Leading means, just now I told you, over excitation. EF cos delta greater than VT. But what is delta? Delta 0, right? If you replace 0 here, what is cos 0? 1. Indirectly, EF greater than VT. This is zero power factor leading. Zero power factor leading, EF greater than VT, correct answer. Next, zero power factor lagging. Whenever I said power factor is 0, cos phi is 0, lagging. Power factor 0 means active power 0. Active power 0 means delta is 0. Okay, but it is lagging. EF cos delta less than VT. If delta is 0, cos 0 is 1, EF less than VT. EF less than VT. EF less than VT. This is wrong. Okay. So therefore, what are the correct statements now? 1, 3, 4 are the correct statements. 1, 3, 4 are the correct statements. So zero power factor is an important observation. Zero power factor means active power is 0. If active power is 0, load angle delta is also equal to 0. Load angle delta is also equal to 0. Clear? Right. So therefore, 1, 3, 4 are the correct statements. If it is a generator, then what will happen? Over excitation will be lagging power factor. Under excitation will be leading power factor. If it is generator. Okay. Fine. Next, one more question. Okay, almost 12 అయిపోయిందండి. మనం సింక్రోనస్ మెషిన్స్ తో కంప్లీట్ చేద్దాం సెషన్. ఇండక్షన్ మెషిన్స్ ఇంకొక సెషన్ రేపు ఎప్పుడైనా డిస్కస్ చేద్దాం అండి. ఓకే, we will complete synchronous machines. A synchronous motor operates at 0.8 power factor lagging. If the field current of the motor is continuously increased, what will happen to power factor? What will happen to armature current? Is the question. See, it's a motor. It's a motor already operating at 0.8 power factor lagging. Field current of the motor continuously increased. Field current, this is something you can answer using V and inverted V curves, right? So we know V curve is drawn between what and what? Armature current and field current. This is how V current will be. V curve will be. And this is leading power factor side. And this is lagging power factor side. This is unity power factor. Okay. Now what is given? Initially machine is operating at 0.8 lagging. That means we are on the left side of the curve. Imagine we are somewhere at this point. At this point, whatever armature current is available, IA1, field current is IF1. Now what they said, the field current continuously increased. If you keep on increasing the field current, how armature current was changing? Is it not, if I keep on increasing the field current, armature current will first decrease and reaches to minimum value. Later, armature current keeps on increasing. So therefore, armature current first decreases and later it will increase. So that is given in the fourth statement. Fourth statement. Second statement was wrong. Now, let us draw inverted V curve also. Inverted V curve is drawn between what and A? Inverted V curve is drawn between power factor and field current. And this is unity power factor, highest power factor. This is leading side. This is lagging side. Machine is already operating at 0.8 power factor. That too lagging, that means we are on the left side of the curve. Now, if the field current keeps on increasing, what will happen? First power factor will increase and it will reach unity. And later the power factor started to decrease. So therefore, power factor increases up to a certain value and later it started to decrease. Okay. So 1, 2 statements are wrong, 3, 4 statements are correct. 3 and 4 statements are correct. Okay. It's a motor. It is a synchronous motor. Okay. So 3 and 4 statements are the correct statements. Okay. Simple. Okay. Look at these questions. There are 6 statements given. We are asked to find out the correct statements. There are 6 statements. Answer the correct statements. Yes. A synchronous machine is floating on an infinite bus bar at no load condition. If its excitation is varied, then it will operate as, okay, yes, alternator with EF less than VT at ZPF leading, EF less than VT at ZPF lagging, EF greater than VT at ZPF, like that 6 statements are given. Just now I discussed it, right? For motor, we already discussed. Now for generator. Remember, all power factors are 0 power factors, 0 power factors, 0 power factor. What is meant by power factor is 0. Power factor 0 means cos phi is 0. Then active power will be 0. Active power 0 means delta is also equal to 0. Now, it is leading. That to alternator. Alternator leading means under excitation. Alternator leading under excitation. Under excitation means what? EF cos delta less than VT. Already delta is 0. Delta 0. Cos 0 is 1. That means EF less than VT. Alternator leading power factor EF less than VT. This is correct. Okay, that means this is wrong, right? Lagging means EF will be greater than VT. Next one, motor. Motor leading power factor. Motor leading power factor. Is it not over excitation? Over excitation means what? EF cos delta greater than VT. Already delta 0. Therefore, EF greater than VT. EF greater than VT, motor leading power factor. Motor leading power factor, EF greater than VT correct. This is wrong. Okay. Alternator EF greater than VT at lagging, this is correct. Motor EF less than VT with lagging power factor, this is correct. So therefore, what are the correct statements? 1, 3, 5, 6. 1, 3, 5, 6 are the correct statements. మీలో ఎంతమంది ఎక్సైటేషన్ అంటే ఈఎఫ్ని వీటీని కంపేర్ చేస్తున్నారు? See, excitation means you should not compare EF and VT. We have to compare EF cos delta and VT అండి. EF cos delta and VT we have to compare, not EF and VT. Fortunately గా ఇక్కడ డెల్టా 0 కాబట్టి cos 0 1 అయిపోయింది. ఓకే, ఎస్, ఓకే. Now look at this question. This is again a simple question. You have to use a simple logic to answer this question. Okay. A synchronous machine is operating at constant load at unity power factor. The machine is at unity power factor. If its excitation is increased, it will operate as. Okay. See, machine is already at unity power factor. Excitation increases. Excitation increases. You can answer this using V curve or inverted V curve. If you take excitation on x-axis, armature current on y-axis, this is the V curve. First we will discuss generator. In a generator, this side is lagging, this side is leading, this is unity. Okay, we are already at unity power factor, guys. Yes, if field current increases, armature current will increase and becomes lagging power factor. Armature current increases and lagging power factor. What about if it is a motor? If it is a motor, same thing, but power factors will change. Right side is leading power factor, left side is lagging power factor. This is unity power factor. So we are already operating at unity power factor. If field current increases, armature current will increase and leading power factor. Armature current increase and leading power factor. So therefore, what are the correct statements now? If it is generator, it becomes leading. That is wrong, right? If it is a motor, it becomes leading. Yes, correct. Generator, it will become lagging. Correct. Motor at lagging, wrong. One more thing. Exporter of reactive power. See, if you increase the field current, okay, machine is coming to right side of the curve is over excitation, right? Over excitation means reactive power is generated. Even here also, over excitation, reactive power is generated. So whether it is generator or motor, it will export reactive power. Yes, it will generate reactive power. Absorb reactive power is wrong. Absorbing reactive power will happen under excitation, that is left side of the curve. Left side of the curve is under excitation, then absorbing reactive power is correct. So therefore, first statement was wrong, second statement was correct, third statement was correct, fourth statement was wrong. So what are the correct statements? 2, 3, 5 are the correct statements. 2, 3, 5 are the correct statements. Always remember, V inverted V curves chala important. Both generator and motor. In generator, right side of the curve is lagging, left side is leading. In motor, right side is leading, left side is lagging. Always remember, right side of the curve indicates over excitation. Over excitation means reactive power is generated. Okay, over excitation means reactive power is generated. Clear? Okay. నెక్స్ట్ సేలియంట్ పోల్ మెషిన్ అండి. ఇది ఆన్సర్ చేయండి సార్. మేము ఆల్రెడీ చదివాం, గుర్తుంది ఆన్సర్ అంటే చెప్పొద్దు. మీరు సాల్వ్ చేసి ప్రూవ్ చేస్తే చెప్పండి ఆన్సర్. ఐ విల్ గివ్ యూ 1 minute టైం. ఓకే, వాట్ ఈస్ ఆన్సర్ ఫర్ దిస్ క్వశ్చన్? ఓన్లీ మీరు ప్రూవ్ చేయగలిగితేనే ఆన్సర్ చెప్పండి. గెస్ చేసి ఆన్సర్ చెప్పొద్దు, లేదంటే సార్ మేము బంబ్రా మొత్తం బై హార్ట్ చేసాం సార్, నాకు ఆన్సర్ తెలుసు అంటే మాత్రం చెప్పొద్దు. నో యూజ్, రైట్? బై హార్టింగ్ విల్ నాట్ గివ్ యూ ఎనీథింగ్. మీరు ప్రూవ్ చేస్తే ఆన్సర్ చెప్పండి నాకు. ఎస్, లెట్ మీ నో ది ఆన్సర్ ఇన్ ద చాట్ బాక్స్. ఫర్ ఏ salient pole synchronous machine with negligible armature resistance, 4 formulas were given. What are the correct formulas? మీరు జనరేటర్ ఫార్ములా ఒక్కటి ఫైండ్ అవుట్ చేస్తే మోటార్ ఫార్ములా ఈజీగా అర్థమైపోతుంది. ఎస్, ఓకేనండి. I will try to answer that. See, to answer such type of questions, you should be able to draw phasor diagram of a salient pole synchronous machine. Okay, so what I will do is that I will consider a salient pole synchronous generator. We will do it for generator, and the same thing we can implement even for motor also. Okay, salient pole synchronous generator. Salient pole generator. Okay, see, what is the KVL equation? In case of salient pole machine, KVL equation is EF is equal to VT plus IDXD drop plus IQXQ drop. In cylindrical rotor machine, only one drop will be available, that is IAXS. But in salient pole machine, two reaction theory concept will be applied. Therefore, we will be having direct reactance drop and quadrature reactance drop. Okay, now to satisfy this KVL equation, I will try to draw the phasor diagram. That too, I will do it for a lagging power factor load. Okay, yes. First of all, it is a generator. Generator means EF phasor will lead, VT phasor will lag, right? By how much angle? Delta, load angle delta. Okay, VT phasor will lag induced EMF by delta. Now, as I considered a lagging power factor, armature current will also lag this terminal voltage by an angle phi. Now, this armature current we can resolve into two components, right? Okay, I will use a different color. So, this armature current we can resolve into two components. This will be direct axis component and this will be quadrature axis component. గుర్తుపెట్టుకోండి, మనకి నార్మల్ క్లాస్ అయితే మొత్తం డెరివేషన్స్ చేస్తాము, ఇక్కడ డైరెక్ట్ గా చెప్తున్నాను నేను. ఏ కాంపోనెంట్ అయితే ఇన్ ఫేజ్ EF ఉంటుందో దట్ ఈస్ quadrature axis component. Okay, now the moment you know this is a direct axis component, what about IDXD drop? It will lead ID by 90 degrees. Here you will get IDXD drop. This is IQ, right? IQXQ drop will lead this IQ by 90 degrees. This is IQXQ drop. Okay, now just to prepare a right angular triangle. ఇక్కడ నుంచి ఒక రైట్ యాంగిల్ ట్రయాంగిల్ ప్రిపేర్ చేయండి. దిస్ ఈస్ 90 degrees, right? So remember, look at this right angular triangle. In this right angular triangle, this angle is delta. So what is this length is equal to VT cos delta. Next, ఈ లెంత్ ఎంత అండి? IDXD కదా, అలాంటప్పుడు ఈ లెంత్ కూడా ఎంత అవుతుంది? IDXD అవుతుంది. So what is the total length now? This total length is nothing but EF, right? So EF is equal to VT cos delta plus IDXD. Therefore, EF is equal to VT cos delta plus IDXD. ఇదంతా ఏ మెషిన్లో అండి? జనరేటర్లో. ఏ పవర్ ఫ్యాక్టర్కి? లాగింగ్ పవర్ ఫ్యాక్టర్కి. అదే మీరు లీడింగ్ పవర్ ఫ్యాక్టర్ కనుక డెరైవ్ చేస్తే ఏమవుతుంది? ఈ ప్లస్ ప్లేస్లో మైనస్ వస్తుంది అంతే. సో హియర్ ప్లస్ ఈస్ ఫర్ లాగింగ్ పవర్ ఫ్యాక్టర్, మైనస్ ఈస్ ఫర్ లీడింగ్ పవర్ ఫ్యాక్టర్. మరి ఇదే మీరు మోటార్కి అప్లై చేస్తే ఏమవుతుందండి? ఎగ్జాక్ట్లీ రివర్స్. ప్లస్ విల్ బికమ్ లీడింగ్ పవర్ ఫ్యాక్టర్, మైనస్ విల్ బికమ్ లాగింగ్ పవర్ ఫ్యాక్టర్. సో రెండింటికి కలిపి రాసేద్దాం ఫార్ములా చూడండి. సో దేర్ ఫోర్ ఇన్ జనరేటర్ వాట్ ఈస్ ద ఫార్ములా? EF is equal to VT cos delta plus or minus IDXD, where plus is for lagging power factor, minus is for leading power factor. అదే గనక సింక్రోనస్ మోటార్ అయితే, ఇన్ మోటార్ వాట్ ఈస్ ద ఫార్ములా? EF is equal to VT cos delta plus or minus IDXD. But this time plus is for leading power factor, minus is for lagging power factor. Now you can go through all the statements and you can understand the correct statement. But ఇది చేయాలంటే ఈ phasor diagram idea ఉండాలి. If you have idea about this phasor diagram, then only you can be able to generate these kind of formulas. Okay, so you must have this phasor diagram idea, then only we can answer such type of problems. Okay, okay, so what are the correct statements now? All the statements are correct. Vt cos delta plus IDXD, generator lagging power factor, generator lo positive sign lagging power factor andi, motor lo positive sign leading power factor. Okay, clear? Okay, yes, so all the 4 statements are correct here. Next, one more question and go through it. Yes, go through this question. For a synchronous machine, the amplitude of electromagnetic and reluctance power are respectively P1 and P2. The respective values of synchronous and synchronizing powers will be what? Okay, ఇక్కడ మనకి cylindrical rotor machine ఇచ్చారు, అలానే salient pole rotor machine కూడా ఇచ్చారండి. Machine A is a round rotor machine, cylindrical rotor. Machine B is a salient pole machine. Okay, so you have to find out active power P as well as PSY, synchronizing power. Okay, that is also known as synchronizing power coefficient P. So for example, if it is a cylindrical rotor machine, it will have only one power component. What is that? Electromagnetic power only, EF into VT by XS into sin delta. You don't find any reluctance power. మనకి electromagnetic power ఎంత ఇచ్చారండి? P1. So therefore it will be P1 sin delta. Indirectly this P1 is the maximum power. All right, so this is the power P. మరి అలాంటప్పుడు PSY ఏమవుతుందండి? PSY, synchronizing power coefficient, is it not dP by d delta? Yes, synchronizing power coefficient is dP by d delta. It will become P1 cos delta. Okay, so synchronous power is P1 sin delta, synchronizing power coefficient is P1 cos delta. P1 sin delta, P1 cos delta, it is in option A as well as in option D. All right, next, what about in salient pole machine? మీకు salient pole machine power flow formula idea ఉందంటే active power, it will have 2 components. One is electromagnetic power component proportional to sin delta. Another one is reluctance power component, 1 by xq minus 1 by xd into sin 2 delta. This is what we call it as reluctance power component. This is electromagnetic power component. Electromagnetic power component is P1, reluctance power component is P2. These are maximum values. Okay, maximum values, P1 and P2 are the maximum values. This is the active power P in salient pole rotor machine. Now what is a synchronizing power coefficient here? Synchronizing power coefficient is dP by d delta. Now what is the derivative for sin delta? It will become cos delta And what about this one? It will become 2p2 cos 2 delta. 2p2 cos 2 delta, right? This is the synchronizing power coefficient. Okay, so that was here. Active power P, sine delta cos sine 2 delta, sine delta sine 2 delta, sine delta sine 2 delta. Synchronizing power coefficient is cos delta cos 2 delta. Cos delta, this is wrong, right? P2, it's not P2, it's 2p2 actually. Cos delta cos 2 delta. I think the last option is completely correct. Here also cos delta cos 2 delta was there. Sine delta sine 2 delta. This is also available. But for both machines, if you see, option D is the correct answer. Option D is the correct answer. మీరు ఇవన్నీ ప్రూవ్ చేయగలిగితే ఆల్ రైట్ అండి. లేదు సార్ నేను బింబ్రాలో క్వశ్చన్లని ఆల్రెడీ చదివాను గుర్తుంది నాకు ఆప్షన్ డి అని చెప్తే మాత్రం మీకు అది ఎగ్జామ్కి పెద్దగా హెల్ప్ అవ్వదు. ఓకే, మీ క్వశ్చన్ ఇలాగే ఎవరు దీన్ని మాడిఫై చేస్తారనమాట. ఓకేనా, కాన్సెప్ట్ తెలిస్తే ఎలాంటి క్వశ్చన్ అయినా ఆన్సర్ చేయొచ్చు. గుర్తుపెట్టుకుంటే అదే క్వశ్చన్ వస్తే ఆన్సర్ చేయగలరు కానీ మారితే మాత్రం చేయలేరు. ఎనీవే, సో దట్ ఈస్ ది కరెక్ట్ ఆన్సర్. ఓకే, వన్ మోర్ క్వశ్చన్ అండి. A synchronous motor having a synchronous speed of 1500 rpm and it slows down to 1490 rpm due to sudden load on the motor shaft. Assuming a south pole on the stator near the damper bars labeled 1, 2, 3, 4, the direction of induced force on the conductor will be. Manaki, what is the purpose of damper winding? And in a synchronous machine, the purpose of damper winding is to reduce the hunting problem. Okay, damper winding should reduce the hunting problem. What is this hunting problem? If load changes suddenly, the rotor speed will change suddenly. So to take the rotor back to synchronous speed, damper winding will help. What is the synchronous speed? At 1500 rpm. That means this stator field is rotating at 1500 rpm. But rotor slows down to 1490 rpm. See, the rotor was rotating at 1490 rpm. ఇప్పుడు ఏం చేస్తుంది డాంపర్ వైండింగ్ అనేది? డాంపర్ వైండింగ్ విల్ క్రియేట్ ఎ టార్క్ ఆర్ ఎ ఫోర్స్ టు టేక్ దిస్ రోటర్ టు ఎన్ఎస్ ఆర్పిఎం అగైన్. మరి ఎన్ఎస్ ఎంత స్పీడ్తో రొటేట్ అవుతుంది? 1500తో రొటేట్ అవుతుంది. రోటార్ మాత్రం 1490తో దగ్గరే ఉంది. అంటే ఇప్పుడు ఈ 1490 1500 అవ్వాలి అంటే డాంపర్ వైండింగ్ మస్ట్ పుష్ ద రోటర్ ఇన్ ద డైరెక్షన్ ఆఫ్ ద ఫీల్డ్ ఆర్ ఆపోజిట్ డైరెక్షన్ ఆఫ్ ద ఫీల్డ్ అండి? ఇన్ ద డైరెక్షన్ ఆఫ్ ద ఫీల్డ్. ఇన్ ద డైరెక్షన్ ఆఫ్ ద ఫీల్డ్ అంటే ఈ యాంటీ క్లాక్ వైజ్ డైరెక్షన్ లోనే టార్క్ క్రియేట్ అవ్వాలి. ఈ డైరెక్షన్ లో అంటే ఏంటి? F1. ద టార్క్ మస్ట్ బి క్రియేటెడ్ ఇన్ ద డైరెక్షన్ ఆఫ్ F1. F1 డైరెక్షన్ లో టార్క్ క్రియేట్ అయితేనే ఈ రోటార్ అనేది యాక్సలరేట్ అవుతుంది. యాక్సలరేట్ అయ్యి ఈ 1490 ఆర్పిఎం అనేది 1500 దగ్గరకు వస్తుంది. గాట్ ఇట్? For example, what if I say rotor speed is not 1490, it was 1510. ఒకవేళ రోటార్ ఓవర్ స్పీడ్ అయింది, అప్పుడు ఏమవుతుంది? డాంపర్ వైండింగ్ విల్ యాక్ట్ ఇన్ ఎ డైరెక్షన్ టు టేక్ ద రోటార్ బ్యాక్ టు సింక్రోనస్ స్పీడ్. అది ఆల్రెడీ ఓవర్ స్పీడ్ లో ఉంది కాబట్టి ఇట్ విల్ ట్రై టు డెసలరేట్ ఇట్. దెన్ ద ఫోర్స్ విల్ బి ఇన్ ద ఆపోజిట్ డైరెక్షన్. దెన్ F3 would have been the correct answer. F3C. Okay, see, the duty of damper winding is to take the rotor back to synchronous speed. To take the rotor back to synchronous speed, the rotor has to accelerate. That's why damper winding will create a torque in the direction of the stator field. In the direction means anti-clockwise. That means left direction, F1. Okay, it will create the torque in the direction of the stator field. Okay, and yes, right. Next, one more question. Please go through it. This is a simple question, Andy. We will wind up the session in the next 5-10 minutes. Okay, already chala late ayindi, 12 దాటిపోయిందండి. List 1 and list 2. List 1 is a synchronous machine. List 2 has a number of phasor diagrams. Which phasor diagrams matching which list? Okay, if you carefully look at the first phasor diagram, you can understand induced EMF is lagging the terminal voltage, right or not? Induced EMF lagging the terminal voltage means it is definitely motor. Here, induced EMF is leading the terminal voltage. It is a generator. Induced EMF lagging the terminal voltage. It's a motor. Induced EMF leading the terminal voltage. This is a generator. Okay. Next, I have to understand over excitation or under excitation. How do you compare excitation? Don't compare EF and VT. We have to compare EF cos delta and VT. Remember, the angle between EF and VT is known as delta. I want EF cos delta. You just do extend this VT, make a 90 degrees angle here. So imagine this is O, this is A. This OA length, this length is EF cos delta. So here EF cos delta is greater than VT. So this is over excitation. Okay. If you want clear, I will erase this. Please understand that. Okay. Okay. So this is EF, this is VT. This length is EF cos delta. EF cos delta. Is it not EF cos delta more than VT? So therefore, first machine is a generator which is overexcited. Overexcited alternator. C is matched with 1. C is matched with 1. Now, coming to the second machine, okay, between EF and delta angle, we have angle delta. Now you prepare a right angular triangle like this. So this length is EF cos delta. So is it not EF cos delta less than VT? EF cos delta less than VT. So this is under excitation. So second diagram is a under excited alternator. So A is matched with 2. A is matched with 2. Similarly, look at this. Angle between EF and VT is delta. So prepare a right angle triangle here. This is EF already. Therefore, this length is EF cos delta. Now, is it not EF cos delta length less than VT? Yes. EF cos delta less than VT. This is under excitation. Under excitation. So therefore, the third one is a motor which is under excited. Under excited synchronous motor. That means this is over excited synchronous motor. Right or not? Correct? Everything is correct, right? Yes. I think I made a mistake here. This is not over excited alternator. First one is motor, right? First one is a motor. First one is a motor. It's a motor. It's over excited synchronous motor. First one is over excited synchronous motor. Okay. This is over excited alternator. Yes. That's all. This is the matching. Yes. First one is a motor. Yes. We decided it's a motor, but over excited motor. Over excited motor. Correct. So to understand which excitation, we should not compare EF and VT. We have to compare EF cos delta and VT. We have to compare EF cos delta and VT. EF cos delta and VT. EF cos delta and VT. Right? Okay. That's all, Andy. It's already been near to 12:30. So almost 50 questions అయితే discuss చేసాం. I thought of solving 70 questions, but time is already very late. So we will conclude the session here. Okay. If possible, I will take one session for induction machines also. Okay. And so tomorrow you have a power electronics, similar session. Shankar sir will take power electronics tomorrow. Okay. So please attend tomorrow's session also. You can solve some quick questions from power electronics subjects. Okay. All right. Thank you so much. Thanks for your patience. And also I appreciate your continuous interaction in the chat box, replying to the questions. I wish you all the very best for your examination. Okay. So have a peaceful night. Okay. Sleep well. Okay. Sleep is very important for last few days. Don't stay much, during overnights. Today is okay. It was happened anyway. Okay. All right. All right, guys. Thank you so much. Thank you. Thank you.